pressure looks good.
Doubling up. Roger, roll, Atlantic.
Water towers, fly!
Flight downside, FTE off. FTE off.
Yikes. You bet. Okay. We don't need any more of these.
My name's on screen, Michael. Thank you. All right, folks. Let us know if you can hear me. John Galloway for NASASpaceflight here, ready to start some live coverage of the Mars 2020 Perseverance rover landing out there at Mars. We've got the NASA Spaceflight crew here with us today so we can do some live commentary. On this side over here, we've got Stephen Marr. Steve, how you doing today?
Oh, I'm great. I'm watching that video. Oh, I'm so pumped. It's taking me back to 2012, watching Curiosity land. Oh, this is exciting.
I was going to do a gag like, all right, congratulations, there was the landing, live stream's over, but that was, of course, the CGI trailer. That was the CGI trailer released by NASA JPL with the ambient sounds and all that sort of stuff. We just figured we'd start off the stream with that. Over on this side, before I get too far into what's going on, Chris Gebhardt, Assistant Managing Editor for NASA Spaceflight. Chris, thank you for joining us today.
Oh, there is no other place I would rather be, because whether I was live on here with you guys, I'd still be in front of my computer watching this like a hawk.
Absolutely. So we are going to be bringing y'all our NASA Spaceflight mode live commentary throughout the course of the day here. You can see we've got a countdown clock up here. We were trying to go live just about 2 hours before it's confirmation. What is our countdown clock to? Somebody help us out.
It is
They can't hear Michael. You have to tell
it
them,
is to
Chris.
confirmation. Yes, it is to confirmation of touchdown. Yes. However, confirmation of touchdown is not the actual time of touchdown, and that's what makes this so cool. Because just like I know, right? So Perseverance is going to be sending back signals, a variety of signals, which we'll talk about, because there are 3 main ones that the vehicle will be transmitting back. as it does its whole entry, descent, and landing sequence. But as it's sending those signals back, it'll take 11 minutes and 22 seconds for it to reach the Deep Space Network dishes at Madrid in Spain. So basically, throughout this whole sequence, when we get the signal here on Earth that Perseverance has entered the Martian atmosphere, it will have already either landed, and that's what we hope, or the bad version of that.
The bad
We don't want to say it.
Yeah,
Don't say it.
exactly. But it will have already landed 5 minutes before we get the signal that it entered the atmosphere. So this is going to be cool, because what we want to do during this stream is show you in real time actually what's supposed to be happening in real time, and then we'll go back and we'll 11 minutes later see those signal confirmations come on into Earth, which will be fun to do.
Sorry, for just a second there, I was a little bit confused because I was like, oh no, our countdown clock doesn't match NASA's countdown clock. I was looking at the top of the screen, and that's not a countdown.
Oh!
That's just the time right
Actual
now.
time,
That's
yeah.
that's the actual time. And it
Well,
happened
so-
to be
well-
so close to the countdown. I was like, wait, no, it doesn't match.
Well, speaking of this, right? Speaking of time, weird time coincidences. So the actual moment of Perseverance's landing on the red planet is scheduled for 3:43 and 42 seconds Eastern.
3:43.
And yes, and it will be received through the Deep Space Network at 3:55:04.
Gotcha.
So 11 and a half minutes later. Yeah. So
Yeah.
but the actual landing time, the local landing time at Jezero Crater, will be 3:53 p.m. mean local solar time.
What?
Oh, cool.
Yes, a total coincidence, but it's almost the exact same time on the eastern time zone here on Earth as it is at the landing site when Perseverance touches down.
So wait a second. They have like Mars time. Like, is there Mars Standard Time or something? What?
There is not. So the way they measure the time on Mars is local solar time. So
Okay.
it's basically local solar noon when the sun is at the highest point, and then you go from there to determine your 24-hour, 36-minute local solar time on the
Okay.
surface. So they don't have time zones. They just go, it's this time where Curiosity is based on where the sun is in the sky.
Gotcha.
That extra
So-
36 minutes that likes to mess with the engineers, and they're constantly moving, shifting their workday to the right, I guess.
That's what I was gonna try. So we have a bunch of really confusing stuff going on. What a great way to start the
Yes.
live stream with the confusing all the times and stuff. Again, if you're just joining us, we are here with the NASA Spaceflight crew. We'd be doing live commentary of the Mars Perseverance landing out there, just under, what's our timer? An hour and 54 minutes away from the time that we should receive confirmation that touches down. And there's all sorts of different things that are going on here, but we'll be doing live commentary. Again, our show's live, and if you have questions for us, one of the reasons we do this is so we can interact with chat and do Q&A and stuff. I know sometimes NASA can't do that, or they're like, tweet us 1 million questions and then we'll answer 3 of them, that sort of thing. But we take questions straight out of chat. If you have a question for us, tag us at NASA Spaceflight. We've got some cool software that's been written that we can actually bring up questions and stuff, do some Q&A. Also, tons of super chats already coming in. Dan Vitale, has everybody got their peanuts ready? Yes, the peanuts ready. Absolutely. So we got super chats coming in as well.
I also
go,
have
Chris.
my celebratory Mars donut for once landing is confirmed.
You have a Mars donut.
You were actually able to get a hold of one. Wow.
Yeah, the one here, the store here in Daytona had them. So I ordered them, and then someone else with the name Chris G also ordered, and we accidentally got their order as well. So we had 24 Mars donuts, and
Oh, that's fun.
some of them had to be given away. That's a
So
lot of
everybody,
donuts.
head on over to Chris G's house. He's divvying out Mars donuts as we speak.
Right?
Oh, geez. So we're going to be here the entire time, folks. Like I said, answering questions, hanging out with y'all, just talking about what's going on. We got some cool tricks up our sleeve. This is actually a live view. This is a live simulation from NASA Eyes. So we'll be providing some of our own coverage. Right now you can see this is the entire spacecraft. It's got the heat shield, it's got the aeroshell, it's got the landing stage. Underneath there, the rover and the sky crane are all in there, but we'll be watching this. I'm curious. I wonder if NASA Eyes is actually going to simulate all the pieces coming off. Do we know if they're doing that or not?
Yes, they should.
They should.
They
going-
should. It should be a real-time visualization of signal receive down to the
signal
surface.
Oh,
Receive.
signal
Okay.
receive. Okay.
Yes.
Right. Oh, that'll be cool.
So wait, signal receive. What does that mean? Does that mean that NASA
So
eyes is going to be illustrating
our time zone? It means our countdown should match what we see from NASA eyes.
As we're
Okay.
hearing the call outs, it should match up.
Yes, as the signals come back to Earth. So like our count is synced for 355. That is synced for 355 as well.
Okay.
Excellent.
So let's talk about that really quickly, because this is going to be a recurring theme on the entire stream here today. We keep talking about, oh, well, landing confirmation versus landing. It's like, well, what? You don't know when it lands? And the trick here is it takes time for the signals to travel between the planets. What's the round trip? I can probably get it on NASA eyes, actually. I should have
on
better.
the Deep Space Network, if you have that pulled up.
Oh, I can get that real quick, but I was going to illustrate it real quick. Let's see here.
Oh, go ahead.
There we go. There's Mars and Earth, right? And the trick with this whole thing is that it takes time for the radio waves to get between Mars and Earth. Even traveling at the speed of light, which one of y'all has that statistic right now? Like, can y'all say, oh, it's this many miles between Mars and Earth right now? Look that up.
No, I can just give it to you in light minutes.
In light minutes, okay.
I can give you the distance to Perseverance. The range is 203.86 million kilometers.
203.86 million kilometers. I'm just going to denote that as a long way. So the distance between Earth and Mars / Perseverance right now is far. I'll write that on the screen like that, okay? And whenever we're talking to the rover or the rover's talking to us, it's not instantaneous communications like every sci-fi movie you've ever seen has had. It actually takes time for that signal to travel from Perseverance. This is a radio wave. Something's wrong with the frequency, but whatever. It sort of varies frequency over time. It's going through different mediums or something. And it takes time for that signal to actually travel from the rover back to Earth. And the amount of time that it takes, what's the light minutes counter?
11 minutes, 22 seconds.
11 minutes and 22 seconds, right? So by the time, if Perseverance wants to say, hey, what's up, NASA? We're cool. What's going on? How are y'all? It actually takes 11 minutes and 22 seconds for that signal to go from Perseverance all the way back to Earth. And if we want to answer Perseverance, we want to say, oh, we're cool, Perseverance. How are you doing? We've got to spend another 11 minutes and 22 seconds. And this changes as Mars gets a little bit further closer to Earth, but back and forth. So it's over 22 minutes round trip time. If you say, turn right or pop your parachute, it takes 11 minutes for that signal to get there, and then 11 minutes for it to get back and say, hey, guess what? I popped the parachute. So none of these things that are happening are NASA in real time saying, hey, Percy, okay, it's time to pop your parachute, because they can't do it that way, right, Chris?
Yeah.
Exactly. It's I believe Bobak tweeted a couple of days ago that the final commands had been sent a couple days ago, and there was no longer any need to update it, and at that point it was in the hands of the landing systems.
So they basically programmed the lander. They've programmed the rover, programmed the lander, programmed the sky crane. Everything is programmed, and it's following sort of a script right now. This is not somebody with a joystick like, oh gosh, there's a crater, dodge it. This is not what happens with these
11 minutes later. Yeah.
Well, you could argue that Perseverance itself has the joystick.
There you go. So what does that mean? I mean, we can't be somebody back on Earth, because it would take us 11 minutes. By the time we saw something was wrong, 11 minutes for us to get the signal that something's wrong, and then 11 minutes for us to say, turn right, or whatever, it's too late, right?
Yeah.
So
Perseverance would be swearing at us, yes.
Gosh. What do they do? Like Perseverance is trying to come in for landing. It's programmed to do all this stuff, but it's not dumb. It's not like it's just following a script and at 3 minutes pop parachute, and then at this time do this. What can Perseverance do that's sort of intelligent?
Yeah, so some of it is based on timing. In the jettisoning of the cruise stage, jettisoning the ballasts, or the balance masses prior to entry, and despin, just nullifying that 4 rotation per minute stabilization spin it's been in for the cruise stage.
Right.
But then once it begins to interact with Mars's atmosphere, it's using its sensors, it's using all of its landing equipment, even the aeroshell and everything, to keep it on course, because when it starts to enter the atmosphere, it's going to encounter pockets of less dense and more dense air that are going to try to nudge it off course. So it's going to be actively trying to guide itself during atmospheric entry to keep itself on track. And then once it's through atmospheric entry, it will be able to realign itself. that's based on some of the input from the overall systems and a timing sequence of events. But what gets really interesting is when we get to parachute deployment. So prior to Perseverance, parachute deployment had been exactly what you just said, Das,
Right.
a timing event, because we kind of knew the basic average elevation of the terrain it was going to head for, right? The interesting thing with Perseverance is there's kind of a difference in altitude that this thing could touch down in its little landing area, right? Especially if it needs to avoid a particular hazard. So a new thing is called so a new thing that they're doing is a range trigger. So Perseverance will be sensing how high it actually is in real time, so that it knows to pop the parachute at 11.9 kilometers to its relative distance to the ground. And then once the parachute pops and the heat shield is deployed from the bottom of it, it will begin actively taking pictures of the surface with its terrain relative navigation system. And it will start comparing those images every single second to the stored images that MRO and Maven have acquired over the years of the landing site. And it will be actively comparing them, going, are the shadows where they're supposed to be? Is everything where it's supposed to be? Or am I headed toward a cliff? Am I headed toward a sand dune? Am I headed toward a boulder? And
Right.
if the answer is I'm headed toward a cliff, boulder, sand dune, impact crater within the impact crater, it will make the decision logic at that moment. Is it safe to touch down there, or do I need to autonomously find another place within a 600-meter circle to touch down?
Sort of
So
pulling Neil Armstrong there.
There you
yeah,
go.
indeed. It's exactly that. Yeah, it's exactly that. Only Perseverance has to do it all on its own, and it has to be
Right.
completely automated.
Now,
And
now
oh
wait a
man, we
second.
talk
Time
about
out.
trust and
Time out.
automation. Come on. Like, this is
We-
the ultimate trusted automation here.
But we probably have a lot of people who are new to spaceflight, or maybe they don't follow it so
Mhm.
much. So we make a joke like, "Oh, pull a Neil Armstrong," and then we're those
Oh,
guys all of a
yes,
sudden. What does
true.
that mean? Like Perseverance is coming in for a landing, and we're like, "Yep, gotta pull a Neil." When we say something like that, what do we mean? That's a reference to Apollo 11, right?
Right. Well, yeah, I was referring to how originally, Apollo 11, they had an automated sequence to come down and land where it's sort of hands off for the most part. But it got to the point where they noticed that they were coming down in a field of boulders that they weren't expecting. So Neil took control and flew himself. And actually, they talk about it in any documentary you watch where
Right.
the descent sort of leveled out. And basically, he was searching for a level terrain with no boulders or anything to touch down. And while, of course, Perseverance, the whole thing's going to be automated, but it has a certain thing that it's looking for. And I'm guessing what Chris is saying is it also has programmed the ability to be like, oh, there's some boulders here that we weren't expecting. Let's divert and figure something else out.
So it used to be that in order to do some sort of real-time intelligent decision-making like that, we'd have to send a meat bag along with the lander, right?
Right.
And yes, I've just referred to Neil Armstrong as a meat bag. Apparently. I mean, a
How
human
dare you,
being
sir.
with some wetware on board to make decisions, right?
How very
now-
Bender of you.
Yeah.
And now we've got to the point where Perseverance actually can be programmed. It's smart enough. It's reading sensors. It's basically got its own eyes and ears and its own feeling of things, and it can divert on its own if it sees, oh, there's a huge boulder down below or something. It's not like Kerbal Space Program where you just drive right through the boulders. Like if there's a boulder, they need to miss it, right?
Yeah.
So
Yeah, indeed. And this is and this is completely new. This vision system that it's got in terrain relative navigation, Curiosity didn't have that.
Right.
So Curiosity was kind of very much we had to be certain there were no major hazards that it couldn't land, right? So we knew you can't put it down here because there are boulders taller than the rover sits on its wheel chassis, right? So you can't put it down on a boulder. But before that, and before these sky crane landings with Curiosity and what Perseverance will attempt here in about an hour and a half, we used to just go, well, we don't have the technology to do that, so we would just inflate airbags 360 degrees around these things and just drop them to the surface of Mars and let them roll.
And that was Spirit and Opportunity, right?
And Sojourner as well.
Yeah,
in
Sojourner
97
too.
did it as well. I got something to show too after I'm talking about Sojourner. But yeah, and I mean, so much so was it like we can't deal with this, so we just have to put airbags on these things and let them land where they land. That Opportunity hit the surface of Mars, bounced and rolled into a crater. And when it opened itself up, the first question became, I hope we can get out of it. But,
We're going to really explore this crater.
Huh.
yes.
I think we lost
So
Chris. Oh, no.
we don't. Did we lose? Wait.
No, sorry, I was looking at something that got posted in our back channel, because there is a different NASA Eyes thing that we can use that shows like range and telemetry and everything.
Yeah,
we were
I
just
think we're
more
waiting
on this
on
for the overall, the overall feel of
yeah, has
where
that
we
one
are
switched
right
to
now.
live mode now? Like, has that one switched to live mode yet? it was gonna do a
Just click
switch.
live button at the bottom is what we're being
Yeah,
told.
no, there's no live button. So
Not yet. Okay, so it hasn't
Yeah.
switched yet. Yeah.
okay, good. Thanks.
Yeah, there we go. But yeah,
All right.
we'll switch to that because there's a lot of cool nitty-gritty detail to get down in that data for for how this thing slows down.
Telemetry screen.
Copy. Zoom wall. Voice check.
I read you 5 by.
I read you 4 by 5. Telemetry status.
Green.
Copy. Try and come in a little bit louder if you can in the future. Otero, voice check. I did not hear that on the net.
555, how me?
I have you 5 by. Telemetry status.
Currently setting up watchers.
Copy. I will try to remember to check. Well, let me know if you have any problems once you feel like you're set up. Thank you. Left lens, voice check.
I read you 5 by. How about me?
I have you 5 by. Telemetry status.
Activity flight.
Telemetry is green.
Go flight.
Copy. Way, voice check.
Can we just position?
I'll read you
the
5
VR
by,
observer?
ops, and telemetry is green.
Copy. I have you 5 by as
by
well.
flight.
Did I miss anyone that has an EDL call out with a voice check?
Turner,
Turner, thank you. How do you read me?
I read you 5 by, how me?
4 by 5. Telemetry status.
I'm go on telemetry.
Great. Sorry about that. Anyone else that I missed?
Cruisinga,
Cruisinga, I read you 5 by. How me?
I read you 5 by as well, and nav is green.
Fantastic. Anyone else? Okay, thank
about
you.
us?
That concludes our EDL voice check. I only noted the
Bye-bye.
issue for McGrew, so we'll work that and keep an eye on Otero. Fantastic. Do we have a new OD Delta table? TAD 1.
This is TAD 1. We do have a update for OD 132. The difference from EPU3 is now 196.9 meters, so it's dropped back to where it was around OD 130.
Do you mind putting that table up on WebEx?
Will do.
All right, so we were just sort of listening into the mission control over there at the literal center of the universe. The joke with the JPL, they've got a thing on the ground that says the center of the universe because that's where all the rovers and everything talk to. And here we've upgraded our tracking to have the live telemetry from NASA Eyes. And this live telemetry, again, this is the one. Do I need to click live? Okay, there, now it's green.
Yeah.
This is the one that's supposed to match the, correct me if I'm wrong on this, the signal receiving.
Yes.
So this is like delayed by 11 minutes and 22 seconds or whatever because of the one-way travel time. All this is going to happen in real life, and then we're going to get signals back from orbiting spacecraft or the rover itself, and then we'll get those signals 11 minutes 22 seconds after they're actually sent, and then we'll know what's happening. But this illustration here, correct me if I'm wrong, but this is the one that's supposed to actually match what we're receiving.
It is, yes. And if you look, our countdown clock is at 1 hour, 38 minutes, 20 seconds, and touchdown time on the live simulation is 1 hour, 37 minutes, 47 seconds. So,
Gotcha.
yes, basically synced. Yes.
Pretty close. Close enough.
Yeah.
We're what,
Yeah,
like
pretty close.
Well, and
28 seconds behind or something.
And it's worth noting too, right? Like if Perseverance encounters a little bit of a thinner atmosphere than average, landing time might be a little bit earlier than the predicted time, right? Just like when something's docking with the International Space Station, and we always say, "Oh, it's docking at 1 p.m.," but it might get there at 12:55.
Right.
Right. It's kind of the same with Perseverance, not as wide of a window. Right. But it's kind of the same with Perseverance. Like you can expect 45 seconds one way or the other. is going to be basically a bullseye, right, to the signal receive time. And a signal receive time too, there's also a 16-second latency between when MRO will get the signal and when it can package it and send it to Earth. So that's part of the Earth receive time and everything.
I'm doing a thing real quick, Chris.
Are you trying to accelerate it to get it?
No. I paused it. I'm going to try to make the clocks match because our clock is intentionally delayed a little bit to match the NASA TV feed that we're getting. And so stand by. I'm going to click go so they match exactly here. Just 1 second. 50, 51, 50, 49.
Go!
Bam.
They don't change it exactly the same time. But it's pretty close. Okay. So we had tried to calibrate our clock with the feed we're getting from NASA, and that's what we're getting on our up there. But I brought up the website, and that was in real time, like actual time, so not taking into account the NASA TV delay because they have a little bit of a latency on their live stream, right? And so now the clock on this screen, of course, as soon as they click away from this, it's going to mess up, should match our countdown clock, which matches the NASA live stream that we're getting. We're getting a clean video feed from JPL so that we can show you things like this without hearing all the hosts talk over it, us and everything. But we've got something like this in the background.
And Das, can I make a request because I memorize most of this in metric? Can we switch that to kilometers, please?
Oh, geez.
Over on the right hand
there
side
it is.
of the screen, second one. Yeah.
There you go.
Thank you.
Back and forth. Jeez. There we go. So it's 20,000 kilometers from the landing site right now. It's still now. That's interesting. Chris, how is the altitude 17,000 kilometers if it's 20,000 kilometers from the landing site?
So it is 17,000 kilometers if you drew a straight line to the Martian surface.
From the surface,
from
straight
the surface.
down.
But Percy isn't going straight down yet. Percy is still coming in at an angle, right?
I think it's the thing y'all talked about last week on NSF Live. You did your little drawing on the screen, comes in at an angle. Yeah, do your little drawing.
Because
I don't know if it'll
right there exactly, like, because you can see the overall trajectory it's on, right? It's not bullseyeing toward the planet. It's that same thing where you don't dive into the atmosphere, you graze into it, and then you let it slow you down and change your trajectory to angle you toward the landing site.
I'm trying to get it. Here we go. Okay, here is the illustration. I can't pan any.
There we go.
But
yes.
The difference between those two numbers is here's the Perseverance landing site right here. Here's Perseverance, Mars 2020. And then here's the surface, right? So straight down like that, that's the 17,000 kilometers. My handwriting's terrible. I was a computer programmer for a long time. I just typed. I never wrote anything. That's a 17. And then it's 20,000 from Mars 2020, the orbiter, or the spacecraft, sorry, not the orbiter, all the way down to the landing site. That's the difference between the two, right?
Exactly. So as the landing sequence unfolds...
Anyways, just delete that. It's not 17 kilometers. It's 17,000 kilometers, but... Go ahead,
yeah,
Chris.
so basically, as it enters the atmosphere, right, you'll see the altitude and range to landing site come into better alignment with one another.
Right.
You can already see they kind of are, right? We're down to 16 and 19 now. Those will start to come into better alignment, and then eventually your range to the launch site. This was incorrect on the preview, and I believe they fixed it for the live one. But the range to the landing site at some point will become 0, even though the altitude is still fairly high, because at a certain point it's descending almost straight down toward the intended target.
Gotcha.
Yeah, so it's not like a landing you're used to seeing on Earth with a plane.
Right. Well, so let's talk about that really quickly. Let me see if I can get this to come up, because if we've got... Where's the Perseverance landing site? Can I zoom in on that? Let's see.
Yeah, you should be able to, yeah.
There we go. I'm trying to get this sort of view, right? And where's Perseverance? Yeah. Off that way. Okay, so there's Perseverance coming in, and then there's the Perseverance landing site. And so we're going to get sort of the atmosphere grazing. Oh, I keep saying loading. It's not going to come straight down like this. It's actually going to come in like this and then land like that, right?
Yep, exactly.
Okay, so I'm not sure why it keeps saying loading there. Maybe there's just so many people hitting the site right now that it's a little slow. But oops. Sorry, drawing on the screen. We'll keep this up so we can continue watching what's going on. So let me do this really quickly. Let me grab some super chats really quick. And Vitaly saying, has everybody got their peanuts? Go ahead, Chris.
Oh, no, sorry. Yes.
Okay.
Just go. Yep.
Dan, we appreciate the support there, and we'll tell the story about the peanuts in just a minute. And let's see, Thomas Anfang as well. It says, thanks NASA for delivering my name to Mars, and a pretty cool rover and helicopter too, I guess. Keep up the great work, y'all. So Thomas, thank you so much for the support. Rough Rider Show sneaking through. Oh, this is a good question real quick. How far away is Perseverance landing from Curiosity? Are they landing like next to each other? Can we have rover races?
They are not landing next to each other. No. Hang on, let me pull that up.
Can you see it on the NASA Eyes app here?
I see Perseverance landing site.
I don't know if they've got Curiosity up there or not. But the basic answer is
saw it there. It said MSL landing site. It's right next
MSL.
to InSight. Yeah. Mars Science Laboratory. That's it.
Yeah. So where is the Perseverance? They like disappear and reappear.
Oh.
Now I can't see the Perseverance landing site. Maybe I have to not click on it.
To basically put it into perspective, Perseverance is like a third of the way around, maybe like a fourth of the way around the planet.
Seeing if we can
from where Curiosity is at Gale Crater.
Gosh, it just keeps taking control of my mouse. There's MSL, and then that's MSL, and there's Perseverance right there. So not quite a quarter, maybe an eighth of a circumference around, maybe.
I'm gonna throw it up in our links document for you here, Das.
Okay, cool. Excellent.
It's labeled landing site, so we can bring it up for everyone. Because
All right.
All right, there's the link for you.
Good deal. Got it. Oh, you put it in the links document. Oh.
Oh, links document. Yes. Sorry.
Yeah.
Yes.
Yes. Continue talking.
Okay. Yeah. So they're not close to one another. Curiosity is not going to be able to see it, or anything like that. There's always the cool question that comes up: will we be able to see it? Like, will one of the other vehicles be able to see the landing? What was interesting is that when the Schiaparelli lander came in October of 2016, there was the possibility of Opportunity seeing it. But unfortunately, Schiaparelli's landing didn't work out as they had hoped, and Opportunity did not see it because of that. But there's always the possibility, because MRO and MAVEN in the Trace Gas Orbiter are all within line of sight range. So the odds of one of them acquiring a photo or a sequence of photos as Perseverance is descending through the atmosphere is quite high. And past
Which we did get that for Curiosity, right?
We did. We got it for Curiosity. We got it for the Phoenix lander as well. When it was coming in over a decade ago. I'm blanking on if we got it for InSight. But there's precedent. If they're within range, they will try to usually grab a photograph or a sequence of photographs of it. So that would be cool, but not real time. It's not like MRO is going to like send a surprise photograph in its in its relay. It is only doing a comms relay.
And I think one thing people might be wondering is if there's going to be live footage, definitely not streamed, but captured. And I think that there are going to be some better cameras on. There are better cameras on board Perseverance than what they had, because with Curiosity, what we got basically was from the point of the heat shield dropping away. We got a bunch of snapshots, but then people were able to take that and do some video magic and make it like a seamless sequence. But doesn't Perseverance actually have a decent video camera to capture a lot of that stuff?
So Perseverance will have, Perseverance does carry a lot more cameras. There is a landing camera on board, not for live broadcast, but it's mainly serving as an engineering camera, so that on playback after landing, when it can transmit that up, so that they can see it. But the landing image system as well, the landing vision system, will be acquiring photographs very rapidly too, as it descends toward the surface as part of its hazard avoidance program. So those would also become available as well after touchdown. for sequencing and stuff like that. So yeah, I mean,
Yes.
there's a lot of cool stuff we're really hoping to get.
Yeah, that'll come over the next few weeks and months and stuff as they download from the rover itself.
Exactly.
Are we getting the audio from the feed right now, Michael? I'm not hearing anything come through, but
Mission manager, all stations
There we
are
go.
go for transmitter off.
Copy flight, go for transmitter off.
so it sounds like they were doing a little bit of a poll there, talking about transmitter off. Anybody know what transmitter off means?
So, so I mean, I didn't hear the specific thing,
Spaceflight.
but there are some
Flight,
things
go
on the
ahead.
cruise stage that are getting shut down in
Please
preparation
perform
for
the
cruise
transmitter
stage
off
separation.
at
It has been doing.
1935
It's been
UTC.
providing power, the data,
Please
the,
copy
Oil
Logan.
one,
the
Tad one,
signaling,
back on net.
communication
All
Copy,
stations
Tad
note
during
that
the
this
cruise
action will
stage.
force
So,
SDST into
transmitter
one-way
off
coherent
might
mode.
have something to
Loss
do
of
with shutting down
telemetry
the
for
cruise
less than
stage
90 seconds is
prior to
expected.
jettisoning it here.
Gotcha.
In a few minutes.
Well, this is Tad
This is going to be a little bit tough for us.
Tad 3, you're going to have to
There's
speak up. Sorry.
a lot of
well,
call-outs going, but they were doing like a poll there. So we don't want to talk over them too much, but we don't want to just listen to them. Like, we want to try and get a balance here. So we're trying to listen to one and balance the other, y'all, is what we're trying to do right there. We're getting all of the audio from them, but we're trying to determine which audio is something we want to use and which audio is something that is just normal call-outs, right, Chris?
Indeed. Do we
Yeah.
do we have
Okay.
any more? Do we want to get back to some questions?
Absolutely.
Yeah.
We
I
had
kind of forgot we were answering those.
No, that's all good. Again, Dan, thank you so much. Thomas Enfang, and then Rough Riders were the three. Let's see here. Grab a couple more super chats. Kylie Williams, thank you so much, saying, "Hey, NSF team, today's a great day to be joining you all, even if it's ridiculously early here in Sydney. Better make some coffee." So again, it's awesome people all over the world watching this spacecraft come down to Mars. Kylie, thank you so much for joining us. Let's see here. Doctor here says, glad this isn't going to be scrubbed. He's stoked. So they cannot scrub the landing of
It
Perseverance.
can't be scrubbed.
One way or another, this is happening. Let me grab just a couple more here. Yeah,
While you're doing
Kylie,
that, I want to point out the velocity indicator there on the screen right now at 11,200 kilometers per hour. That will peak at roughly 19,000 kilometers per hour.
Because they're actually falling right now. They're falling towards Mars.
Exactly. Mars's gravity is starting to hug it and pull it in like it wants.
Yeah, there's
so
nothing on
that'll
there
peak.
pushing it. It's just gravity.
Yep, totally. Yep.
all right.
So
let's see.
anyway,
Here's
just wanted to point that out because that's a huge increase.
Yeah, absolutely. Kylie Williams, another one from Kylie here, saying, I think some of the NASA team will be setting records in the longest time you can hold your breath. 11.5 minutes is a world record for holding your breath. I wonder if that's actually a world record for breath holding.
We'll find out today.
Yeah. Let's see, everybody.
Also, disclaimer: don't try that. Yes.
Just remember to
don't try
breathe.
it.
Just
You're
remember
not
to
Jacques
breathe.
Cousteau. Isn't that the guy? Isn't that the one that
the I think so.
the free diver that held his
Yeah.
breath the longest? Yeah.
I think so.
Here's another one from Rikin Patel saying, will we get photos of it landing? So do we have any expectation what sort of photos we maybe get back? Photos or videos, y'all?
So the first part of that is a very important. Nothing live. There will be no live video or photographs being sent back by the rover during landing. After landing, we are anticipating that when the rover begins to wake up and activate its systems and it starts taking its situational awareness photos and its documentation of how am I and what am I near, those will either come in very quickly through the Mars Reconnaissance Orbiter, or we might have to wait a few hours for them. And the trick is we don't know, because a lot of it is going to depend on exactly where inside the landing circle Perseverance actually touches down. If it touches down closer to the cliffs, which would thrill the scientists, absolutely thrill the scientists, there is a larger percentage chance that MRO will cross out of line of sight range and go below the local horizon before before Perseverance can transmit the photos up to it. So it's just going to depend where in Jezero Crater it touches down, and does MRO still have a line of sight? If not, MAVEN and the Trace Gas Orbiter, MAVEN from NASA and Trace Gas Orbiter from the European Space Agency, will still have line of sight to it. but they are not configured to immediately retransmit. So they take it, compile it, and then send it.
It's like store it locally or something, right?
Exactly, because they have to process it inside of themselves to turn around and meet the signals, the signal frequencies to send it back, basically. So we hope to get them. We're just not sure exactly when. So
how many of the Mars orbiters are built to be relays like that? Or do we, like every one that we send, do we make sure that they also have the ability to relay signals? Is the Hope orbiter built to be able to do that once it's ready to go?
It is. Hope can serve as a communications relay as well. And you hit it exactly right, Stephen. So we design all of them with that as basically their secondary mission. So Maven, Trace Gas, Mars Reconnaissance, Alamal, they have their main mission that they're doing. You can stop them at some point and let them serve as communication relays, like is happening today. But you have to specially configure them if you want it to be an instant relay. And we only really need one of those. So that's why MRO got the job, because MRO is well past its primary science mission by well over a decade at this point. While Maven and Tracegas are still in their main scientific missions. So we haven't completely reconfigured them to be primarily comm relays yet, but they help. And even Maven, like talking to the rovers on the surface, will grab data from Curiosity as it's going overhead, package it, and send it back. And Alamal will be able to do that too, because we build these things like MRO to well outlast their scientific uses, because we know we need them as a communications net. And then they just sort of transition into comm satellites as they get older and older. But MRO is still doing a lot of good science and imaging. But yeah, exactly that.
So does everybody understand what these guys are talking about? Let's draw it real quick, shall we? We're talking about
thank you, Das.
I mean, I think we should draw it. I just think that we should put it up on the screen.
Das is the person who went, that wasn't English, Chris. How do you do this?
Well, no, it's all good. I just I want to make sure. I know there's a ton of people that get super excited about events like this, and sometimes we sit here to talk about, MRO and Maven and this, that, and we'll relay the signal. And sometimes it's like, let's bring it down to Earth, or let's bring it down to Mars, I guess, today a little bit, and show what we're talking about. So while ever, this thing is still doing its loading thing. So we'll tell it to, wow, that entire thing just crashed. I got like a website error when I tried to refresh that page. But the spacecraft's headed out to Mars, right? And I'm going to, let's just get a nice clean screen here. We'll just draw on, that's the shop. That's not a clean screen. Let's just get a nice clean screen here that we can draw on. And imagine you have Mars over here, right? Like this, and you got Earth way over here. I'm going to draw it smaller. It's not that it's it's just that it's far away, okay? And so what happens is we've got these big dishes on Earth, part of the DSN, the Deep Space Network. That's a satellite dish pointing off of Earth, right? And it's trying to talk to the rover. And right now,
bigger than Earth, apparently.
It is. It's going to get signal, okay? So can you hear me now? Sort of deal. But these dishes on Earth can talk directly to the rover, directly to the spacecraft. So right now this thing is sort of cruising down towards Mars. This is the spacecraft with this descent stage, and it's just sort of sending a signal back to DSN, and these big dishes can get that signal, right? But the trick is sometimes the rover may be in a place, or the spacecraft may be in a place where it can't talk directly back to the big dishes. So imagine we come over here and we land on Mars like this, and then Mars rotates, and we're looking at it from the top or whatever, and you end up with your little rover over on this side of Mars, right? Let's put a little arm on it and whatever. Okay, that's the rover on the wrong side of Mars. And when Mars is between, the actual physical part of Mars is between our dish back at Earth and the rover's antenna, it can't talk to Earth. It can't transmit through Mars. So all this stuff we've been talking about, when we're talking about Maven and these sorts of things, we're talking about other spacecraft that are in orbit around Mars, like this, that may be able to talk to the rover when Earth can't talk to the rover. So it may be the sort of thing where we're bouncing a signal around Mars. Like imagine you're sending a signal up to here, and then the spacecraft, the orbiter, is sending it back. Or it may be where the spacecraft is on the dark side of Mars. Like even the spacecraft can't talk to Earth, but the rover can still send data up to the spacecraft. And then the spacecraft can hold on to it, and when it orbits around, over to the other side, then it can get signal back to Earth, and it can say, hey, while you were gone, I picked up all this mail for you. I'm going to send it to you now. So all the stuff that we're talking about, like, oh, we're going to use a relay and we'll bounce it and we'll store it here and that sort of thing, it's literally just, can the rover talk directly to Earth? Or does it need a friend in orbit around Mars to help gather up that information and then send it when it's possible to send it? It may even be like a burst sort of thing where you send data up and then it sort of trickles over a little bit more slowly when it's from one of the links. But just to sort of roll it back together, it's not. I know we love our technical jargon and we love our acronyms and all that sort of stuff, but a lot of the times it's like, what are these people talking about? So many new people show up for these sorts of events. I want to make sure that sometimes we sort of step back and say, okay, what do we mean when we say that? Does it make sense? Did I get that?
Right.
No,
years ago, I wouldn't have known anything that he just said. But yeah.
Well, no, and Das, it's exactly what we always say on the stream, right? Like, eventually one of us is going to say an acronym and someone's going to go, I don't know what that means. Ask us. We're not purposefully trying to, obscure what's going on. Exactly. We're not trying to do that. And we will answer anything. Yeah.
Absolutely. And especially as you get these big Mars missions, this happens every time there's a big Mars mission. It's not just everybody over here in the USA saying, yay, we're sending a rover. There's interest all over the world, right? People all over the world are watching the broadcast right now. We do this it's sort of a trick sometimes. It's fun to see where people are watching from, and then chat is going to be completely worthless for a minute. But what I want people to do really quickly, because people all over the world tune into broadcasts like this, they get excited about stuff. Let me know where you're watching from. Okay, yeah, there goes Chad.
There they go. Brazil,
Germany,
Algeria, Bulgaria.
Florida was in there. Go, Steve, read some.
Wow, I can't now.
Get
Michigan, Boston, Poland, Denmark, Scotland, Turkey, Netherlands, Norway, UK.
Shout out to the person who said Earth.
I didn't see that one. Minneapolis, Manchester, UK, Toronto, Reno, Texas. Oh, Texas. Well, we're thinking about
I'm glad you have power.
Stay safe out there.
Yeah, seriously.
Yeah, there's been a lot of focus on Mars today, but we're thinking about you guys out there in Texas.
So, y'all, wherever you're watching from, all over the chat is just going to
Morocco,
keep scrolling forever here. Wherever you're watching from, thank you so much for joining us as we hang out and provide. It's not going to stop, does it?
It's fun.
It's awesome.
Miami, Greensboro.
Someday I'd love to. I kind of really one day want to do like a map of like how many countries we're watching.
Oh yeah,
that'd be fun. Yeah. Oh,
that'd be cool. We need
Morocco.
some chat software.
You can also see we're drawing our uncertainty corridor as we get closer to Mars into the gravity well. It's less Mars is starting to tell us where we really are, and you can see that in the lower right corner, where you can see actually nicely how Mars is really telling where it is, and the uncertainty ellipses have been nicely collapsing. We're actually pretty close to EPU3 we put on board, so that looks good. So then to continue, what to expect as we go into EDL, you see here at first we're actually still in outer space, and then actually at one point, this will be the top plot on your screen, you'll see that we rapidly decelerate in the atmosphere and then actually go to parachute deploy at the hopefully at the end, and then we'll go further. We'll just zoom in on that a little bit. So this just shows you more zoom in of that, and we'll do that actually during the EDL so you can get a good look at all. And you can also see all the events that are going to happen, put dashed lines because they're not quite certain at what time they exactly occur, but it should be close. So we'll also have a bottom plot which will show actually where we actually try to model what's going on. So that takes a big thing.
It's interesting here. It sounds like they're describing some stuff that they're not actually giving us on that video feed. They're talking about some telemetry. I don't know if that's just for mission control, but we're not getting the screen that they're talking about there.
Yeah, I wasn't sure if we were stuck on the NASA eyes or if
No. We switched back over to the feed we were getting from JPL, but it did not include that imagery there. I was listening in, and then it was a little confusing because they were describing things that we weren't seeing.
Yeah, something in the lower right, but there was nothing there.
No. So those would have been like the data packets that the controllers were looking at, because they're getting fed not the live thing that we're looking at right here, right? They're getting basically what they were saying, right? It's how to describe this? Okay, so there's a hurricane coming, right? And 5 days out, the cone is really, really wide. And then 2 days out, the cone is really, really narrow, right? And then 1 day out, you have a fairly good idea where it's going to make landfall, but then 12 hours out you have an even better idea, and then 3 hours out you have an even better idea. That's basically what they were saying. As they're getting closer and closer, the real-time predictions and how Perseverance's landing software is saying, okay, where am I actually? What is the gravitational effect? What am I seeing? How am I refining the timeline and the uncertainty there? So it goes back to what I was saying, is there is some uncertainty in the timing of things based on what they said because of certain events. And Perseverance is just starting to narrow that down, and the uncertainty is starting to peel away. So basically, it's a good guidance solution that's being locked onto here.
Gotcha. And just to be clear for people that maybe haven't ever seen anything like this, when they say uncertainty, that's not a bad thing. Uncertainty is expected. This is real life compared to, obviously they have their plans, but when you do this in reality, there is going to be naturally some uncertainty.
And that's a great point, Stephen. And to be clear too, they actually build that in, right? So Perseverance is capable. So there's a uncertainty window that's built into what the landing systems can handle to get you to the surface. And all they're saying is we're more in the center, right? So we're not going to need the margin that we have built into the system,
right? Because
we're nailing it.
Because we're nailing it.
You know?
We're doing great. We're doing great, kids.
Nice. Again, y'all, if you're just joining us, we're the NASA Spaceflight crew. We're doing some live commentary for the Mars 2020 Perseverance landing. That's coming up. What's our clock say? 1 hour and 11 minutes. We've got a countdown going. That countdown is when we should receive confirmation back from Mars. It has a little bit of a signal delay built into it, but we will be here until that happens, answering some questions and stuff like that. I'm John Galloway with NASA Spaceflight, and joining me right above me is Chris Gebhardt right there. Say hi, Chris, real quick.
Hello,
there's Chris,
everyone.
And at the very top, Stephen Marr. Steve, say hi real quick.
Hello there, everyone.
Excellent. So that is what we are doing. I'm going to see if we can't find a question real quick here. Let's grab some questions out of chat. We talked about this one. We already talked about this one. Maybe we can speed run some of these. But William Burroughs asking, why does the simulation show the spacecraft speeding up? We talked a little bit about that. That's the gravity of Mars actually pulling the spacecraft down, right? Chris was going like this. Now he's...
Keep going. Okay, I'm going to make sure of something.
So
yeah, go.
So after launch, as Perseverance is rocketing away from Earth and a little bit away from the sun, it's actually decelerating slowly, but it is decelerating some. But as it gets closer to Mars, it gets in what they call the sphere of influence. It's close enough for the gravity to actually have an effect on it. It actually begins falling back to Mars, not back because it's never been there, but it starts falling towards Mars. If maybe a way for people to relate is if you've ever seen the movie Apollo 13, they talk about how on their way back from the moon, they're actually falling and accelerating towards the Earth, and that's why they come in at such crazy speeds, right? And that's sort of what's happening here. The closer Perseverance gets to Mars, the more of an effect that gravity has on it, and the more acceleration there is. So it's just going to be constantly accelerating until it starts to hit the atmosphere, and the atmosphere is able to slow it down.
Yeah, that's exactly right. And let me see if I can do this real quick. If my drawings are too much, let me know. But we do this with our museum shows all the time. Imagine you've got like Earth, right? This is just going to be Earth over on this side, and then imagine that you've got Mars over on this side, right? Like that. Not to scale, all right? At least Mars is red. If you were standing on, if they weren't to scale,
Earth, we would be in trouble.
Exactly. I had time to paint them. They're just not to scale. If you were standing on Earth and you tried to jump, right, you would go up a little bit depending on how strong you can jump, and then Earth's gravity would put you back down again, right? You just go up and go down again. And even if you could jump really high, you'd have to jump up really high, but Earth's gravity would still pull you back. And sort of simplistically, what's sort of happening here is this spacecraft, this is an estimate, like a way of explaining it. This spacecraft, because of all the energy that it had in the rocket, was able to jump so high that it wasn't going to fall back down to Earth. It reached escape velocity from Earth. So it jumped away from Earth so hard that Earth wasn't pulling it back down very strongly. It wasn't pulling it down enough to stop it. But what happened is it started to get closer to Mars, and it was as if it had started on Mars and tried to jump off Mars. The same exact thing. If you were standing on Mars and you jumped, Mars's gravity would pull you back down again. And once the spacecraft got close enough to Mars, it was almost, it is specifically as if Mars gravity is pulling it back down. So when we say that it's accelerating, it's because it's just like you jump and you go up and then you stop and you start to fall back down. If you're Wile E. Coyote, you stop for a little bit longer, right? But when you fall back down again, that's the gravity of the planet that you're nearby. You're in the sphere of influence for Mars that's actually accelerating you down for the planet. When we go back over to this right here, is it this one? Yeah, here we go. That's why we're seeing that velocity increase. Because curiosity, whoa. Velocity, curiosity, it rhymes. Because Perseverance is actually falling towards Mars right now. The gravity of Mars is pulling it closer or faster and faster towards the planet. Did I get that pretty correct?
Completely.
Sounds good to me.
Yeah.
Right. So I do museum shows, and we have like outreach stuff for kids, and we draw these things on the screen. We play Kerbal Space Program and stuff. So trying to turn some of those things, we say, what happens if you jump, right? And it's a good way to imagine what's happening with the gravity and the spheres of influences and stuff like that. So if I get a little over the top with my drawings, let me know. I like to draw. And the pen's red, and we're going to Mars.
And for those of you that do play Kerbal out there, in the Kerbal world, that sphere of influence is a hard line, but in the real actual universe, it's more like a gradient. I mean, every body in the universe has an amount of influence on everything else, but obviously you have to be a certain distance to really be able to get that.
Local time, we will make the transition to EDL main mode. That will be 45 minutes from the entry interface. Upon that transition, we will save surface nominal to NPM and also ARM second chance. We will disable all system fault protection. We will mark our EDL critical devices healthy, TDS, the DIMUs, DMCA, and VCE. We will set our vehicle configuration to cruise and our vehicle configuration history to surface. We'll disable any remaining CBM windows, which there should be none, and we'll mask the alarm clock wake-ups for both the cruise and descent stage PAMs. After that transition, we'll have an approximate 5-minute wait until the continuation of the EDL start anchor, which will start at approximately 12:08 local time. In the EDL start anchor, we will power off the LCAM heater. We'll disable the DSDST radio state 1 timeout. We will set our up-loss timer to 80 hours. We'll disable the DMCA fault protection and the DIMU and LVS thermal fault protection. We will power on our backup REPA. We will then stop AMAN and reacquire our pseudo-celestial IMU knowledge and sync our nav filter. We'll change our CBM row to EDL reserve two-way non-coherent. This row reinforces CBM windows disabled. Our packetization will be on. It will turn off ranging and switch to the auxiliary oscillator. We will then start our real-time data products, reinforce medley on, and reinforce our remaining heater device states for EDL. At this point, we will be 34.5 minutes from entry. We will have a long 16.5-minute wait until the next autonomous anchor, which will occur at 12:30 local time. That next anchor is the EDL prep anchor. During this anchor, in preparation for cruise stage separation, the EDL nav filter will take the best inertial attitude knowledge from ACS and continue to propagate it via the DIMU. It will then idle ACS and IVP since they're no longer needed for attitude determination. We'll start the DIMU raw data product. We will disable TDS thermal FP and power on UHF, although we will not yet be transmitting. At this point, we will be 17.5 minutes from entry. The next anchor will come quickly in 2 minutes at 12:34 local time. In the HRS vent anchor, in preparation for firing our pyros, we will set the BCB discharge FETs on and the BCB charge FETs off. We'll power on the pyro firing cards and arm the rover pyro bus. We will power off the cruise stage devices and stop flight software communication to the PAMs, all in preparation for cruise stage separation. And then we will fire our pyros to vent the HRS liquid and gas. We will then be 13.5 minutes from entry. We'll be 2 minutes from the next anchor, which is cruise stage separation. In cruise stage separation, we will start the X-band EDL tones, and UHF will start transmitting. We will initiate the descent stage thermal batteries and open the power dead face relays between all stages. We will fire the PV1 and 2 to enable the descent stage prop system. We'll then perform our cruise stage sequence using our pyros. At that point, we would have transitioned to EDL commentary for the remaining until landing.
Sounds like a big explanation there.
Yeah, I was just going to say, basically what they're doing is they're walking the team through everything they're expecting to see, right? Because this is automated. So when he was saying, like, we will disable, it's the command systems within the rover's landing systems that are disabling or converting, and these are the signals they're expecting to see in the telemetry stream coming back at those particular times. Basically, they're just walking the team through the incredibly complicated timeline of entry, descent, and landing, which we are summarizing as cruise stage separation. Entry, landing, parachute. But that was just the really hardcore engineering stuff that they're expecting to see in the telemetry streams.
Yeah, and you got to realize this is a very important thing. You know, we see the spacecraft and we see the rover and we see all these cool pictures and stuff, and then we get this with launch day as well all the time. A rocket launches and it's exciting, yeah, okay, and then tomorrow you don't hear much about it, right? This mission is the result of thousands of people working tens of thousands of hours. So when we hear all these little checklists and call-outs and all the things that have to happen, right, that stuff didn't just magically appear in the rover. It's because someone designed this mission and programmed it, and they checked it, and they rechecked it, and they tested it, and they just all the different things that have to go in. They're not just sitting there twiddling their thumbs. They're making sure they're keeping track of everything. They will get to a point where they can only listen in. They can only get the signal back and see what happens. But all of this culmination, you got the big day of launch day, big exciting event. Yeah, it's launch day, and then everybody forgets. People had to work for 10 years to make this happen, and then it's going to be out there operating for 10 years. A lot of people don't remember that, you know?
Yeah. Well, it's the reason I wanted the tweet to be to all the engineers, to all the technicians, to everyone who poured so many years into this, and it literally just comes down to all that reliability we baked into it.
Yep.
Yeah.
Absolutely.
And you know, sort of to that end, I want to talk a little bit about the engines things. Stephen, there's a couple of messages in our back channel for you.
And also, we just crossed an hour.
And we just did cross an hour.
Yeah. So less than an hour when it should actually touch down, and we should get confirmation in just about an hour now.
Exactly. Yeah. So we were talking about reliability, right? And Perseverance has some interesting elements, right? That you know, there's no room for error on,
right?
And those are the engines that it will use, both the engines to stop its spin, the engines the thrusters to keep it oriented correctly as it's coming into the atmosphere, and then those 8 critical descent thrusters on the descent stage for retro rocket propulsion. All of those systems are provided by Aerojet Rocketdyne, who's one of the best out there in terms of this type of engine reliability, both for human missions and robotic missions. So, you know, worth giving that shout out to Aerojet Rocketdyne for that reliability that we know has to be here, because all 8 of those engines have to fire when that descent stage drops, and ooh.
And that's, I'm trying to see if we've got, because we've got some images of stuff like that, but it's, you know, bringing it up at the right exact time. Here is a picture, I think, of the engines you're talking about. This is all from the, this is the pre-landing simulation. Let's see what this looks like when I bring it over here real quick. Those are the 8 engines you're talking about, and this is specifically from the descent stage throttle down there, right?
This is exactly it. And you know, from Aerojet Rocketdyne, you know, what these are primarily designed to do is they need to slow that vehicle down. So these are what Aerojet refers to as the MR107U thrusters,
right?
Which are the ones that will stabilize. Not these, sorry. Which are the ones that will stabilize it during atmospheric entry. And then there are the 8 MR80B throttleable thrusters, which is what you see here and what will be used for the landing. So as they're burning propellant, right, they need to throttle them so that you always maintain a negative thrust to weight ratio, or thrust to weight ratio less than 1, right? Because you want to keep descending, but you want to be slowing as you're descending, but you don't want to get a thrust to weight ratio greater than 1, because then you start ascending back up, right? And basically what we mean by that in terms of thrust to weight ratio is like the thrusters are firing at basically they're outputting enough energy that's countering the entire weight of the vehicle, right, to help slow it down and stabilize it. But you don't want the weight of the vehicle to drop below what the thrusters are firing at, because then you start going up like a rocket.
Right. Like in Kerbal.
Like in Kerbal, exactly. So those engines are throttleable, and 4 of them will actually be turned off as it gets down to that hovering stage. Where it's hovering between 16 and 20 meters above the surface as the sky crane winch lowers the vehicle the rest of the way to the surface. But those are the engines that have to work perfectly.
Yeah. Good deal. Again, y'all, we're now less than an hour away. And I see a bunch of people like, oh, you're not live, click live. We had this timed with our countdown, which is up at right up here, see? Right, and that was matched with a JPL video we were getting, because NASA sends us video on like a 32-second delay or 28-second delay or something like that. So there's a little bit of confusion there. I understand that this should be green. I mean, I can certainly click on green, and I think if we've done it right, yeah, now that live matches our clock, but the NASA video will not match. So when we get mission control cheering, because y'all want this to be green, whenever NASA comes back, they're going to be 30 seconds behind whenever we show you mission control, because mission control, that video feed we get is on about a 30-second intentional delay from NASA. And that's why we had everything synced together. But the outcome of that was it didn't say live on the screen and people screaming, "Das, it's not live, click live." Well, it was all synchronized. That was why it was that way. But now it's green. Anyways. Let me see if I can get a couple more.
While you're looking for questions, that thing that I was trying to confirm in the background. So earlier on in the stream, we had that call out of transmitter off. That was actually a call out in relation to the Deep Space Network, turning off the transmitter and getting into final hands-off configuration to receive the telemetry signals that will be coming back during the critical EDL sequence. So that was just the call out that the Madrid dishes were configured for the landing as they should be.
Okay. I'm getting some more information over here real quick. Let me grab a question for y'all really quickly. Do we know? So here's a good question from Random Vite. I guess, how many cameras do the rover and lander stage have? Do we know how many different cameras or angles? Because there's some different things that we haven't had before, right? Any information
I saw that
on
number earlier.
Yeah.
It's dozens,
it's not,
right?
It's not like 2. I think it's like 20
Hang
cameras
on,
or something like that.
Yeah, I'm looking for it.
Yeah. I think it's like 19... 20, 21. I think it's over 20. A bunch of people in chat are saying 23.
Okay. Yeah.
Noah doesn't have any idea.
A lot of people saying 23.
Yeah. In any event, more than 20. Let's go with more than 20 cameras on the rover, lander stage, etc., etc. A good question. One of those questions that we don't always have the answer to real quickly. We could certainly Google it, but let's go on and grab
diving for the press kit.
Yeah, the press kit, and we can look it up in the press kit and stuff. We haven't memorized every single thing about this. Let's
Total
see.
cameras. It says right here on the what is this page? It's just it's a NASA page about the rover. It's 23.
Here we go.
23.
Yeah.
All right.
23. Engineering cameras 9, science cameras 7, entry, descent, and landing cameras 7.
There
we go.
23.
There we go.
Does the helicopter have one?
I don't. Oh.
I'm pretty sure. Yeah.
I think it does. Yeah.
It's going to be able to. Yeah. They've talked about how it can take aerial photos.
Yeah. That's right.
Yeah.
That's right. Yeah.
Yeah.
Man, for a minute, Das, you asked that question. I was like, oh, right. The helicopter.
Oh, it's the whole thing we haven't talked about is the helicopter, right?
The helicopter, the ride-along payload. Yeah.
The other cool thing is that it has microphones on board. So
Yes.
we should get audio, not live, right? But we should be able to download the audio recording of what it sounds like as it's going through all this, right?
Yes, because the microphones are nicely part of some of the scientific objectives of the mission. So you've got them, and you can kind of turn them on a little bit earlier and gain some additional and use them in two different ways. But yes, the microphones are really cool because they're not just for the landing descent, but they're also for some of the science that it's going to be doing as well.
Gotcha.
Yeah, that is going to be awesome. Getting to, I mean, because we've sort of heard Mars before. You know, they've taken data and transferred it into sound
audio format.
Right. But these are actual microphones on board the rover that will be recording the Martian atmosphere. It's going to be so cool.
And one of my favorite pieces of trivia about the Curiosity mission, Perseverance's cousin, is that on the 1 Earth year anniversary of its landing, they configured the rover to sing happy birthday to itself.
Hey, when you're the only one around, I guess.
Right.
In the thin Martian atmosphere, happy birthday just doesn't have the same ring. You have to vibrate your structure in order to hear it.
You have to shout it just to be able to hear you.
Right. Hello.
Let me grab some more of the super chats here really quickly. We got those. Some of these.
I put a link into our links document for the camera info right under the press kit. If you want to show that, it's got a nice image there showing.
Oh yeah.
Yeah, showing all the cameras.
Grab that real quick. Just 1 second. Let's see here, and we'll read some super chats as well. There. Oh well, there you go. What can we make that look like? Like that?
Yes.
There's the answer. Sometimes it takes a couple seconds to get the answer, but there's the answer. Supercam, Mastcam Z, Navcam, rear has cams. I mean, it's got a camera called Sherlock and Watson. Nice.
It does indeed part of the scientific experiment. Sherlock and Pixel are part of it. Yep. But while we're here, I want to point out. So the entry, descent, and landing cameras, right, are obviously on the bottom of the vehicle. And the front hazard and rear hazard cameras, right, are those first images that we can expect, right, are where they're coming from. And they are the initial, like, where am I situational awareness images we're going to get once it's on the surface are going to come from those front and rear hazard cams. And those are the ones that we're not quite sure if we'll get them in time before MRO goes over the horizon. Right.
All right. Really quickly, this is another thing that sort of people don't understand a lot of the times. Can one of the NASA spaceflight people find us a picture of a person standing next to the rover?
They took a selfie with it, yes.
Yeah.
They took selfies with it.
Grab a picture of it. Put it in the control room if you could real quick. And I want to show that because that's something that people don't get. You think this is like an RC car driving around on Mars? No, this is like an SUV driving around on Mars.
It's huge. They've actually got a life-size one at the Kennedy Space Center Visitor Complex. And it's incredible. It's like, whoa. Like, you kind of have this image in your mind of how big it is, and you know it's big. They told you it's big. And they said, it's about the size of an SUV. But then when you actually see it, like that mass cam it's higher than your head. Even, I'm about 6 foot, and I'm not that tall, but I'm kind of tall, and I'm looking up at it. Crazy.
And I can grab that real quick here. Let's see.
Hang on. Sorry. I'm trying to get you the link.
Yeah. What is that, Brady? What is that? Brady got a picture there that I can show real quick.
Oh, okay, good.
Yeah, but we'll just bring it over here like that and toss it in there. As I drag it onto my screen.
Oh, yes, that's the family.
That's the family.
Yes.
The family. Yeah.
Awesome.
Yes. So, and I wanted to point this out too, because I love this stuff, right? So, like, they several years ago they made Curiosity, and they made a Perseverance as well this year. And
is that a Hot Wheels?
And in 1997, I still have my original Sojourner from 1997.
Nice.
Wow,
oh, that's cool.
Yes, so collect the Hot Wheels toys while they're out for these.
I've got the Curiosity Hot Wheels one also. Mine's still in the package. If
anybody's seen The Martian, isn't this the one that Matt Damon got? Like he didn't even recover that, and he was driving it around like an RC car.
Oh
pretty
gosh,
sure,
I think so. It's
right?
been a while since I've seen that movie. I think so. Yes.
Yeah. So you think you're like, oh, it's an RC car. It just drives around and bumps into your foot. No, it would run over your foot. Okay, it's huge.
Well, that one would probably just bump your foot. Curiosity and Perseverance would just knock you down and keep going.
Yes.
Yeah. Roll over you.
Yeah, or just roll over you. Yeah. No, that's a good size comparison of the three though, because the smaller one was Sojourner back in '97.
Yep.
The medium-sized one was Spirit and Opportunity, which got there in 2003, and then Curiosity and Perseverance on the other side. Yeah.
Good deal. So we're coming up on 45 minutes before we should get a confirmation on what has happened out there today at Mars. Again, it's going to happen in less time than that. It's going to happen
in about 18 minutes.
Yeah.
It starts.
Wait, about 18. Oh, so when the
is
EDL
when
starts?
Crew stage separation will actually happen. So
Gotcha.
Crew stage separation will actually happen at 3:26 and roughly 53 seconds Eastern time. But then it won't be until 3:38 p.m. that we receive that confirmation signal back here on Earth.
And our altitude's halved. I mean, we were up at what, like 17,000. Now we're at 7,500. So in the time that we've been here running our mouths, it has halved the distance to Mars, and it's going even faster. You can see the velocity is still increasing as Mars' gravity continues to accelerate it towards the planet. It's one of the tricks about landing on a planet like this. You think, oh, okay, I'll just ease up and then land. No, as you're coming towards the planet is actually like, all right, cool, come here, and the gravity's pulling you down faster and faster the closer you get.
Yeah, like if you're driving a car and you start accelerating towards a wall. Like you see there's a wall coming up and you just hit the gas.
Yeah, and then you try to slam on the brakes at the exact same time while throwing pieces off of your car. It's like, doors don't need that, trunk don't need that.
I think I'll go study that wall.
Yeah.
Oh, good deal. So that is continuing to come up. We're listening in. We do have the countdown net up, and they're doing a lot of normal callouts and stuff. For big stuff, we are playing the audio for the actual JPL countdown net. Let me grab some more super chats just really quickly here. Here's a good question from Robin saying, I was thinking recently, if we colonize Mars, what could a calendar look like? Like, how would we differentiate Martian time? Are we going to keep using UTC? Do we need Martian local time? Like, how does that work? Martian daylight savings time. Can you imagine?
Oh, good Lord.
Hopefully they'll just do away with the daylight savings thing once you get to Mars.
Oh, please, let's not take that time, the idea of time changes.
Oh.
Yeah, to Mars.
We may be getting some audio here from Mission Control. Let's see.
So far are all expected. Copy activity. Okay, Phase 2, you want to continue the description you were giving?
Yeah, sure, Flight. So right now we're doing two things. We're taking this opportunity to reinforce the state of the spacecraft. A lot of the actions that we're doing right now, the devices are already in this state. This is something that we do just to make sure that the spacecraft is in the state we want it after any type of fall protection responses may have been executing. Of course, we didn't have that situation today, but that's why some of these actions are here. Since we've started the EDL start anchor, we have gone ahead and turned on the backup REPA. We've also turned off the LCAM heater, which was preheating the LCAM to the appropriate temperature for the beginning of EDL, so we can so it can coast down thermally and be at the right temperature when we use it later on, just before backshell step. We also have our RCS cat beds still on and heating up those thruster cat beds as we prepare to fire them for the first time during guided entry. We should have no change in our avionics state except for our UREANet that we saw at the beginning. And our flight software execution state should remain the same. But the backup computer running Second Chance will have armed itself and prepared
it is prepared to take over as we go through EDL if we should experience any type of reset from the prime computer.
OL1 back on that.
Copy that. OL for 2.
Copy.
As we speak, we are transitioning CBM states, and I think activity is going to give us a little more information on that in their update.
Yeah, copy phase. The CBM change, as I mentioned previously, is to the EDL reserve two-way non-coherent
Right
route.
here, activity.
Copy flight.
EDL phase, go ahead.
I'd like to see pep talk, I guess, to the team. All right. I'm terrible at pep talks. I think my reputation precedes me there. And look, I know this hasn't been easy, right? I'm not even sure we've even been all in the same room at the same time. I mean, I'm staring at folks across the internet as well. Even now, right? Only. Yeah. Voice check. Okay. I do want to just extend my heartfelt appreciation from the EDL team to the launch cruise team. You've done everything we've asked for, right? I mean, you've battled anomalies, you've dealt with Cephis, you've done everything. You delivered a healthy spacecraft to the place that we want to go, and she's right on target, right? We did the last maneuver literally 2 months ago, right? This is pretty incredible, in my opinion. And she's armed with the right information to help us land. Doing the parameter update last night, we're ready to roll. You've done everything right. And you've put up with us too, right? You've put up with our eccentricities and the things we like to do in EDL land. So I very much appreciate that. So you all should sleep in on Friday, since you guys have earned it. Thanks for literally and figuratively putting us in the right position to succeed. And let's land on Mars together.
Copy EDL phase. And as flight director, I also would like to thank the whole team, cruise ops, EDL ops, EDL team, and the surface ops as well. It's been an amazing journey. I think we all know that. And it's been my honor and pleasure to work with you all side by side. And your tireless efforts and endurance in the face of our challenges has been truly, truly inspiring. So kudos to you. Mission, would you like to say something?
Yeah, just echoing the same words that Al and Magdi have mentioned. You guys have overcome great obstacles in the last 6.5 months, and it started with an earthquake in this room on launch day at L-20 minutes. So I can't be more proud than all of the achievements that you guys have pulled off in the last 6.5 months. Whatever happens in the next hour and a half, you can be proud of the achievements that you've accomplished so far. I look forward to seeing you on the other side, and I only wish that the rest of our team could be sharing this moment with us. This is a very unusual event. This room is only half as full as it would be if we weren't in this pandemic. So missing everybody on the team who's not with us here today. And go EDL.
Welcome to the EDL family.
Yeah, all right, y'all. Listening into some of the pep talks there, right?
The final word. It really was, and I do just want to make sure we clarify that they were talking about, like we're doing. I want to make sure that this is clear, that what they're referring to is what the spacecraft is doing. They're using like a royal we, because they're not sending commands to the vehicle. In fact, they said over there that the final parameter update was sent last night, and they have not updated anything since. Wonderfully enough, the backup computer is called Second Chance.
Second Chance. Did y'all hear that? The second, just in case the primary computer goes down, the other computer they call Second Chance. So.
Second Chance. I love it. But you can also hear the tension in the room. This, and I think this is a good point to talk a little bit about getting to Mars, right? We have heard very recently, especially last week, when Alamal and Tianwen-1 from the United Arab Emirates and People's Republic of China successfully arrived, people made a large deal about saying, oh, there's a less than 50% chance of getting to Mars, which is true when you look at it from the pure historical standpoint, from the very first attempt to, not including Perseverance, just going up to Tianwen, because we don't know how to classify Perseverance yet as success or not. But to me, that I kind of got interested because, you hear that, but then I started thinking, well, in the last 20 years, how many have we actually lost? And I started counting it back in my head and came to the realization that, not counting Perseverance, since the 21st century began, we've sent 17 vehicles to Mars, and 13 of them have gotten there safely. So the odds in the 21st century...
Talking peanut for all of us.
They're talking about their peanuts there.
Okay, so the odds in the 21st century are more upwards of 75% chance of success with the technology that we've had. And I think that's a very important thing. Like, yes, nerves are tight. There's no there's no ability to interfere, right? It's all up to, does it work? We have every degree of confidence it will. History is on our side. NASA's experience is on our side, because remarkably, when it comes to rovers, NASA has a 100% success rate. So the odds are in our favor, but that doesn't mean there's not nervousness from the team.
Yeah.
And peanuts, Das, you were just mentioning, so I think this is a good moment to talk about the peanuts, because this is part of landing day. Yes.
It is. It's sort of a tradition that's like 50 years old, and so they just came on the net there talking about the peanuts, right? So like, these are actually, I don't know, whatever brand, but they actually have some. It's been a long-standing thing where, sort of to break the tension, they would pass around the snacks in mission control, and everybody's there all tense. So what's going to happen? They've worked for years on this, and 50 years ago, one of the people at mission control had some snacks and literally started passing around the peanuts so that people could just, you have a snack and you feel a little bit better. And to this day, there is still a sort of ceremonial jar of peanuts in mission control at JPL, where they go on lunch day and they all sort of share it. Now, of course, different circumstances here. I haven't heard, do they have like individual airplane peanut bags, or how have they dealt with that, I wonder? I haven't heard that specifically. I've got some here though, so.
Yes, because as much as this is technical, as much as this is scientific, we have our superstitions. And when something works, because you had peanuts there, you have peanuts at every subsequent event.
and that's like, what's the saying? Luck has nothing to do with it, but we'll take all we can get. Like,
yes.
Hey, if there's, I know at Kennedy Space Center, they actually have like a cookie bar on one side of the place, and if you go into the press place, the press area at KSC, there is a shelf, or like a counter that has cookies on it a lot of the times for the press people covering things. So anyways,
indeed.
We are now we're coming up on 30 minutes again. To clarify, that's when we should get the confirmation back, right? So
this is what I want to go for now, Das, is we are 6 minutes away in actual time from the separation of the cruise stage.
Right.
Although we are still a ways away from, although at 11 minutes of that, so we're 17 minutes away from getting confirmation of that.
Right.
And this live thing is synced to the confirmations. So I think a cool thing to do is to call things out as they're actually happening.
Sure.
So that people can get a sense of the time delay that we're dealing with, and why is mission control so nervous?
And just to be sure, make sure I get this right, this animation that NASA's giving us here, this is tied to the confirmation. So what we'll see, we'll say, okay, now the spacecraft should be separating that, but we won't see it here in the animation until 11 minutes later, 11 minutes, 20-something seconds later, when we would have received the signal from the spacecraft saying that it had done the thing, right?
That is what they have said, yes.
Okay, that's what they've told us. That's how this is supposed to work. So.
Yes, and to be fair, our clock is synced with the Earth signal receive time for landing confirmation of 3:55 p.m., and their touchdown clock in live says 33 minutes as well. So,
okay.
Yes.
Good deal. Yeah. So just everybody on the same page with that. There is the delay. It takes a little bit over 11 minutes for the signal of whatever happens to get from Mars back to Earth. It'll already have been on the surface, or have really been on the surface for 5 minutes once we even hear anything back from it, once it gets into the atmospheric entry and the touchdown. So there is that big delay, and that's one of the confusing things about what's going on. But this animation is supposed to be when we hear about it, and then we'll say out loud, all right, right now it should be separating, but we won't see that in real time.
Right.
Let me see here. What's the speed of Perseverance? So we've got that on the stream right now. You can see it continues to go up 14,000 kilometers per hour, it looks like.
And it will peak at roughly just over 19,000 kilometers per hour. And interestingly enough, it will actually peak after entry interface, after the moment that it enters Mars's atmosphere, because Mars's atmosphere is so tenuous and thin up in its upper layers that it's not thick enough to start slowing the vehicle down yet. So it won't. So it'll take about 45-ish seconds to begin actually slowing the vehicle down from its peak.
Start feeling the atmosphere, right?
Yeah.
Gotcha. It's like technically in the atmosphere, but there's not enough of it to really do anything yet.
Exactly.
All right.
It's technically in the environment, but it's
not in the environment. Technically, hey, actually, the front's going to fall off, like intentionally. The front is going to fall off from these guys. Whichever way you slice it, whether you think that the cruise stage is the front or the heat shield's the front, both ends are going to fall off this thing. It's supposed to happen.
Fall off.
There are going to be some epically dramatic moments here as this thing, like it really is. I mean, we do like to joke about it because it helps break some of the tension, but you know, like this is not the equivalent of like a play it safe landing. This is equivalent to like the Hail Mary at the end of the game. Except your Hail Mary is equipped with a bunch of technology to make sure it's caught by the receiver.
To make sure it's caught in the end zone. Nice. Not just in the end zone, like exactly on the the logo of your team on this side of the end zone and this part of the T and the logo, like a very specific part where it needs to be caught for sure.
But and with joking aside too, like all of these systems have been tested. We have tested them here on Earth. We have tested them and put them through their paces as much as we possibly can. A lot of the systems are very similar to what was used to successfully get Curiosity to the surface of Jezero Crater in August of 2012. There are some new things, but again, I really do want to emphasize 75% success rate in the 21st century overall globally, and NASA has a 100% success rate when it comes to rovers. The odds are definitely in the favor of Perseverance here today. Yes.
Y'all, I got to do this. There's tons of super chats that are coming in, and there's no way that we'll be able to read them all. It's not even possible. A lot of times when we're just hanging out for 6 hours watching Starship testing or whatever, we read all the super chats. There's no way we're going to be able to do that today. If you've done a super chat, thank you so much, but we're not going to have a chance to read them all.
Out of EDL start. That's our last real reinforcement of the state that the vehicle was in throughout much of cruise and EDL approach. And it's our precursor to making many more radical changes to the state of the vehicle. Matt Wallace said it well the other day. EDL is kind of like a controlled disassembly of the vehicle. As we go through, we need to get rid of the things we don't need anymore and get ready to put our wheels on the ground. So one of the final things that we're doing here is ensuring that our ACS knowledge is top-notch. We depend on ACS to pass an estimate of the vehicle's attitude and rate of change to EDL, and that's our starting point for propagating down to the ground. When we come up in the EDL prep anchor is when we'll take the last state from ACS, and we'll be propagating from that point to the ground until we get more knowledge from the radar once we turn it on. I can give a high-level overview of some of the events that are going to transpire throughout EDL. Of course, commentary will be detailing this as we go through, and you'll hear a lot of members of the EDL team calling out specific events as they occur and indicators as we see them. But to give everyone an idea of what we're going to see, we will first start shortly here. We'll get news that the vehicle has separated the cruise stage since we no longer need that. We need to prepare for entry into the atmosphere. After that, we will indeed start the entry process. At this point, we're depending on the heat shield to both protect the spacecraft and help slow us down. We'll be gathering data from our Medley sensors, and we'll be decelerating rapidly at that point. As we make our way through the atmosphere, we'll be firing our DRCS thrusters that poke out the back of the back shell, and this will allow us to steer our trajectory as we make our way through the atmosphere. This is one of the things that allowed MSL, the Curiosity rover, to land where it did. And we're depending on the same type of entry guidance this time around to help get us very close to our target. As we make our way through entry, finish our guided entry profile, we'll do a maneuver called heading alignment, where we point toward the target and get ready to deploy the parachute. But before we deploy the parachute, we need to get rid of a set of balance masses that have been giving us a center of gravity, or CG offset, throughout the guided entry phase. So these are called the entry balance masses. We also call this maneuver SUFR, S-U-F-R, or straighten up and fly right. So we'll go ahead and eject those masses when we get a trigger from the GNC system telling us that we're at the appropriate range to the target to do so. As soon as we deploy those, we will no longer have a CG offset, and we'll be ready to deploy the parachute 17 seconds later. I'm going to hold here for EDL prep as we're about to start that anchor.
Yeah. Okay, y'all, we're listening in again to JPL mission control there as Mars 2020 approaches. Well, Mars. It's not going to Saturn or anywhere. They would have named it Saturn 2020 if they were.
Wait,
but
where's this thing going?
Where's it going? Oh, no, it's the wrong planet. No, but we're listening into mission control on occasion, and I think these things have already started to happen, right, Chris? Like, we're already well into the spacecraft starting to execute all the things it needs to do. That's one of the confusing things here. The spacecraft is sort of on autopilot now, right?
Yeah, the first three major events already happened while they were going over what was going to happen
Right.
with the team. So, like, the cruise stage has already separated. The spacecraft has already despun itself. And the cruise balance mass ejection has already actually occurred in real time.
Yeah. So this is an interesting thing to see. Here's something we can use. Right here, you see how it says next phase despin in 8 minutes and 48 seconds? If that number is less than 11 minutes and 22 seconds, it's already happened. And right now, for a lot of things, not everything I think is going to get the signal, but right now, the spacecraft has sent this signal and it said, hey, I did this thing. And that signal is traveling between the Earth, or between Mars and the Earth right now. It's on the way to Earth, but it's not here yet. It takes it 11 minutes for the signal to get from Mars to Earth. So if that number is less than 11, it's already happened in real world, and we just haven't gotten the signal confirmation that it's actually happened back here at Earth, because we're a long way away from Mars right now.
Right. So that signal right now is still being transmitted directly from the vehicle itself. So even with what we're seeing in the animation on the screen in terms of what we've already received and what's actually happening right now at Mars, it's still just Perseverance sending that signal back, not being relayed through MRO. Although MRO will be within range to see it. The trick is that MRO actually has direct line of sight back to Earth for the main communications part down until the back shell separates. So after the parachute deploys and when it's released to start the retrofire descent, it can see Earth until that moment in time. It's after that it really needs MRO to bounce the signal for the Mars Reconnaissance Orbiter to bounce the signal back to Earth. So
I'm sorry, Chris. I'm laughing over here because the guy that runs our store, our National Spaceflight store, sent me something that was relevant to what you were talking about. Because Apparently, he has taken my illustration. I don't think this is an actual product on the store right now. I don't know. But
well, clearly there's somebody wearing it right there.
Yeah.
It's on, they superimposed it or something like that.
Photos
this is not
don't
a real
photographer.
Right.
This is not a real T-shirt that's for sale or anything like that. There are things for sale on the shop, but if I refresh, I don't think that that's actually on the shop. If that's something that, why would anybody want to wear a T-shirt that had that on it? But we've got all sorts of stuff. Another way, like I was saying, the super chats before, another cool way to support the stream is to head on over to shop.nasaspaceflight.com. We've got these awesome prints from, it's Tale of Two Starships. Nice. This is actually some aerial photos we got down from Boca Chica. We've got some of Mary's fantastic sunrises in here. Where do I get to the sunrises? Oh, no, it's a new shop. I don't actually, wall art. Look at that. You can just click on wall art. In some of the fantastic sunrises we get from Boca Chica, you get prints of all these different things. T-shirts, if you're wondering when SpaceX is going to do a hop, et cetera, all that's over here on the shop. We'll put a link in the chat. See if you can crash it. Last time we linked it to less people than this, it crashed the shop. But that was, I was laughing in the background because this came across one of my side screens. And I was like, you've got to be kidding me. Nobody better show up wearing this shirt. Back to Mars 2020. Sorry about that.
Well, Stephen, I've actually got a question for you because we are about 2 minutes, about 2 minutes away, or 3 minutes away from Perseverance in real time hitting the atmosphere and starting here. So I want to go back to a very different atmosphere that we got to see it in. Can you talk a little bit about the experience of photographing it leaving Earth 7 months ago?
That was arguably like the most important mission that I've ever photographed. You know, it was kind of like you know, I photographed a lot of rockets taking off, and always in the back of my mind, I try to not put too much pressure on myself because, you know, I'll get to see other rockets launch, but you only get to see so many missions leave Earth for Mars, you know, and especially Mars 2020 Perseverance, such a huge thing. And it was, yeah, it was incredible. I was very happy with the photographs. It was such a beautiful morning. It was an early morning. The sun wasn't that high up. You know, what time was launch? It was
7:50 or something like that.
Yeah, something like that. Yeah, and so the light was beautiful. Actually, I don't know how much people care about that, but I was like, oh, this is early. That early morning light, sort of the golden hour, and.
These are all yours, right, Steve? Like these are your photos that I've got here, right?
Yeah, that's the one that I took from the press site at the ITL Causeway, and I've also got a couple that are there you go. There's one of my pad shots. That's actually one of my favorite of all time. It's just I mean the Atlas V is always. Wait, I'm sorry. Was that comms?
No, that was me saying I love it.
Okay.
Sorry.
Okay. Yeah. The Atlas V. I love photographing the Atlas V, but knowing that Perseverance is inside that fairing right there, it's important, you know. So actually, this time I did actually let myself feel a little more pressure. It's like I gotta nail this out because I want to have some great photos to remember this by. And then I also have a photo of the engines that got it there. The liquid engine with, you know, what is it? RL10? Is that? Am I thinking right?
The RD-180 and the AJ-60s.
Right.
Yeah.
Just so much power there. They had 4 solid boosters on there, and then the RD-180 pushing it off the Earth. It's just incredible. And actually, I had a lot of opportunities to practice on photographing the Atlas V before this launch. So I really feel like that came out pretty good. And then there was another one of it in flight where I sort of did like similar settings to kind of get the detail of the flames coming out the back, right?
Yeah.
And one thing, I don't know if it comes across on the stream, but one thing I noticed when I was editing it, and I wasn't sure if it was like a weird noise pattern, but you can actually see shock waves coming out, like starting just below the fairing and kind of ballooning out around the vehicle.
Look at that. That's cool. It sounds like it's getting fast and furious over here at Mission Control here. So again, y'all, these are some of Steven's photos. We'll put a link into chat so you can go and check out some of these photos up close. But we're now, well into what's supposed to be happening with the spacecraft, right?
Wow.
I think so.
Getting
We're going to
close.
bring that audio back in here real quick here.
Time information
So again,
until
there we go.
about 9-10 minutes from now, once the Mars Reconnaissance Orbiter starts relaying information from Perseverance. We are under a minute from cruise stage separation, about 10.5 minutes from entry interface.
And again, when they say they're under a minute from cruise stage separation, that's confirmation that it's happened, right?
You're seeing the heartbeat tone.
Yeah, it already happened several minutes ago, and what she just said there, 10 minutes to entry interface, it's already in the atmosphere.
And
it's already in the atmosphere.
Yeah,
I'd
it's
like to point
already
out-
done that. Yeah, and it's heading toward guidance. Actually, the guidance system has already started.
We're
It's
continuing
past
to
peak
receive
heating
tones from
at this
Perseverance,
point,
coming
and it is
standby
just
for
about
cruise
ready to
stage
start its
separation.
heading alignment to shed more weight and begin a more vertical descent down toward the
timing?
surface. Yeah.
And so that was the illustration of the cruise stage actually separating.
Cruise stage sep.
We have indication that cruise stage separation has been confirmed by the spacecraft.
Yes.
So it's good. Again, it's already
In
happened,
1
but
minute,
they just got
Perseverance's
signal.
landing software will wake up and begin the final preparations for entry. The first action it will do is to fire warm-up pulses with its entry thrusters. These pulses ensure that the spacecraft gets the thrust that it wants during entry interface. We're about 9 minutes from entry interface.
So it's already in the entry interface, but we'll hear about it in 9 minutes. That's what's so confusing about all this, is because Mars being 11 minutes away, things have already happened, and then it takes us a while to hear about it. So what we're watching here is the confirmation. It's not the illustration of what's happening in real time. It's actually the confirmation, NASA JPL receiving word that, yes, the cruise stage has separated and will be...
Confirmation that we got shadowed by the cruise stage as it passed through our beam to the Earth.
Oh,
interesting.
Telecom
That's interesting.
indicated actually that we could see a signal that the cruise stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream
RCS
indicating cruise
warm-up?
stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. Warm-up pulses have begun.
Spin down.
At this point, the spacecraft is trying to stop its spin
CBM?
from the cruise 2 revolutions per minute down to 0, and then will turn to its desired orientation from entry. It will
CTE.
separate the 2 balance mass that has kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry attitude. We're about 7.5 minutes from entry interface.
And we're about 3 minutes from real life landing.
That's so confusing. So I'm not even exactly sure how to talk about this. Like, it's already well into the atmosphere.
Yeah. And you don't want to get going on a tangent.
MR reports carrier log. MR. The DTE from Radio Science from Green Bank reports carrier log. You see the carrier on the downlink.
Flight level 1.
We are continuing to wait for entry interface. We're about 6 minutes and 45 seconds from entry interface. We have confirmation from Greenback that they are receiving direct-to-Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones. These tones indicate that Perseverance is operating normally and has nothing significant to report.
So Green Bank is one
This
of
is as
the
expected.
dishes we use to
We're
listen.
currently just over 6 minutes from entry interface.
I got that right? Green Bank is one of the, like, what they're saying is that they are getting a heartbeat from the spacecraft. The carrier is just the signal. It is a signal coming back from the spacecraft, and they're getting that signal, which is good. If you saw somebody in mission control, they did like the yeah motion whenever they got confirmation that they were getting that downlink.
We're just under, we're about 5.5 minutes from entry interface. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth.
That's 11:22 right there. So that was 11:22. Right around this time frame, the spacecraft is either landed or it's not. It's right around that time, right, y'all?
Yep.
Continue to report heartbeat tones, indicating everything is nominal.
So now it's all just signal. The radio waves of whatever have happened in the real world on Mars are making their way towards Earth. And JPL mission controllers that you're hearing and seeing here, they're relaying back to us what it is that they're getting.
Reports the electro radio is powered on, ready to receive signals from the lander.
There you go. So they're talking about those signals as they reach Earth.
Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
Flight Local 1
from entry interface.
And again, y'all, we're doing our best not to talk over. We don't want to talk over their callouts.
Around this time, a second spacecraft, Maven, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're currently at about 3 minutes until entry interface.
So basically, we'll get confirmation of landing, and then we won't get much else for a few hours.
Right. Like the videos and stuff like that they were talking about, it sounds like.
I was hoping we'd at least get that initial photo like we did with Curiosity.
Did they say what MRO's range is? Because Maven is not the one that would transmit those photos. It would be the Mars Reconnaissance Orbiter.
Okay.
Yeah, we'll listen in and see what they say.
And that's the one that pre-landing they said it's totally dependent on where it actually touches down inside Jezero Crater.
Minutes from entry interface, Perseverance is to transmit heartbeat tones, indicating everything is nominal.
And again, that entry interface point they keep talking about, that's when it starts to get into the Martian atmosphere. Now, it's already in the Martian atmosphere. It's been in the Martian atmosphere, but those signals are making their way back towards Earth. We're hearing them as they reach Earth.
Yeah, it's almost somewhere on the surface right now.
It's either on the surface or it's really on the surface.
Or it might be under the surface.
Or in it.
Yeah. We're in the surface, right.
We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second. We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry.
It's almost like watching your latest show where the show's already aired, like people know what happens. The lander, the rover knows what happens, but we have to stay and we're just watching the episode 11 minutes delayed from real time.
We are 1 minute from entry interface.
Oh, man.
MROs are in receive mode.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Wow.
Confirm UHF data flow.
About seconds from
M7W
entry interface.
on.
5.3 kilometers per second and an altitude of about 150 kilometers from the surface of Mars.
So this looks like that interface they were telling us about earlier, showing the telemetry as it comes back. More than 5 kilometers per second right now.
Entry.
Just got the call out.
Confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars.
So the deep space dishes, so 4 of the 5 deep space dishes at Madrid have either...
Is now waiting until it begins feeling the atmosphere of Mars to slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target.
Doppler indicates entry into the atmosphere.
At Madrid have
Navigation
MRO
is also
and all of them,
confirming
as
that
do the
we can
Goldstone
see
arrays.
a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
Plasma blackout is where they can't get a signal out because of the plasma around the spacecraft as it goes through the atmosphere.
Same thing that happens when astronauts come back.
MRO has lost log.
And the velocity is dropping like a rock here.
Reversal.
We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its
max
distance
10
to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Doppler indicated reversal.
Bank 2 complete.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target.
Doppler indicated reversal.
It's coming up on Suffer here. They're straighten up and fly right.
Range minus 1.9 kilometers. Cross range minus 2.4 kilometers.
Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, but to the target on Mars, but instead is flying straight to the target.
Can you imagine? Like you get one chance for this to happen. It's not like, oh, do over, oh, revert, oh, F9, 5 F9. Like that's not how this is.
Yeah, revert to launch site.
Yeah, and you can see how vertical that descent's going to get in a minute there.
Yeah. It's 15 kilometers
Our
up.
current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
So 11.9 kilometers up is when the parachute should pop.
MRO is reporting good telemetry log.
We are coming upon the
Software start.
We are starting the straighten up and fly right maneuver,
UBMD jettison.
where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
So they clapped.
Doing its job.
Yeah, that's not a simulation. They got confirmation that the parachute was doing its job. That wasn't like it's supposed to. That's
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the camera
to get terrain relative
their first
navigation.
look
This is
at the
making sure
Current
there are no
velocity
hazards
is
in the
145
area.
meters per second at an altitude of about 9.5
new
kilometers
thing.
above the surface.
Yeah, this is the new part of the sequence. So
again, these are signals reaching Earth, like confirmation signals coming back to Earth, saying what's going on. Now it's already happened.
What has already happened?
What has already happened? Yeah,
Nav
exactly.
filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Still getting those signals back.
OVS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative
it
navigation.
knows where to land.
Priming.
It knows where to land. It's found the no hazard
priming
area.
of the landing engines.
Backshell set.
Is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the backshell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
Flying out of the hamburger.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars.
SDS level.
Constant velocity
104.
accordion. Constant velocity accordion, altitude error.
We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct to Earth tones.
Throttle down.
Sky crane maneuver has started.
Oh, man.
About 20 meters.
Tango
off the
Delta.
surface.
Yes!
Nominal.
Yeah!
Oh!
Yeah!
We're getting signals from MRO.
Bring me stable.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. At this point, the descent stage has flown away to a safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
God, we got the Tango Delta TV, right? Tango Delta,
I
and we're like,
that. Yeah, I remember that from Curiosity. I didn't know at the time during Curiosity, but they said Tango Delta nominal, and everyone's like quiet until he finally says touchdown confirmed.
Yeah.
But yeah, so this time I heard Tango
No
Delta.
reports.
Ooh.
Tango Delta, where's the nominal?
From the lander.
Oh man.
All right, all stations. Touchdown confirmed. We're going to wait for the images.
They're going to wait for the images. Nice. So touchdown confirmed. They're going to wait for the images. So the 7 minutes of terror, everything that it had to go through to get safely to the surface of Mars, everything, just to translate what just happened, we just got the signals back to Earth that it is successfully touched down on Mars. It's talking to MRO, the Mars Reconnaissance Orbiter. It's bouncing signals off a spacecraft. That spacecraft is sending signals back to us. 11.5 minutes almost. Those signals came all the way back to Earth, and we have confirmation. Tango Delta nominal confirmation of touchdown.
We now know what Perseverance knew 11 minutes ago.
11 minutes ago.
OL3, OL1, you have what you need?
The nerve-wracking part of that, though, is that
we have seen the completion of EDL 3000.
Tango Delta is just, it touched the ground. Now we have to make sure it releases from the sky crane, and the sky crane doesn't come crashing down onto it. Like, that's why, like, it's like touchdown. It's like...
I was like, oh, wait a minute. I guess there's more to that.
Flight, this is OL3. I am ready to share.
OL3, you are go.
Ready for you to share.
For those on M...
All stations, stand by for the images.
Yes! Stand by for the images.
They got him. They got him.
Come on, show me.
Wait a second.
Yes. Look at that. Look at that.
Full screen that.
Look at that. That's from either the forward or the rear hazard cam. Look at that.
Flight
enhanced,
OL3.
nice.
I have the target point on the map when you are ready. We are ready, OL3. Go for it.
They're like, send it. Little picture.
Oh my goodness. Oh.
They sound happy.
What a release for them, right? You know, to finally have
Flight,
this.
I'll be moving in, showing you the safe zone that we've landed in.
Oh my goodness.
Awesome.
Look at that! Look at that!
Yes!
That's from one of the Haz cams, right, Chris?
Oh my God, that's one of the hazard cams, yeah. Look at that.
Oh, it's beautiful.
Yo, it's not the first picture we've seen from the surface of the red planet, but it's a new camera that we've deployed to the surface of the red planet.
And one thing worth noting is these cameras have covers on them.
TRN.
What?
So the cameras.
Can we get the cliff image, OL?
There's going to be a lot of stuff happening here.
Yeah, I know. But the pictures will be better. They have covers on them for
Activity,
the
this is
landing.
OL. Can you repeat that request on M20 EDL off?
OL, can we get the other image to show the cliff?
Show the cliff.
How close are they to the
far?
cliffs?
How far?
Yes.
Again, I'm not understanding.
Flight OL3. OL3.
Is that this is Find Dog?
Yes, it is. They haven't. This
we've
is Find
landed
Doll.
About 35 meters from the nearest rocks that we could identify from orbit by their shadows.
35 meters from the nearest
DRN
rock.
in action.
Yep.
Wow.
Let's see
Take
if
that,
they get this-
Jezero. Woo!
What? Take that. Did you just say take that, Jezero?
I remember this spot. It looks good. Copy OL3. I'm sure that you have seen them all and you recognize them all.
Look at there. There's the other
Look at
ones.
that. So it's downloading more pictures, basically.
It's
Yeah.
like it's or
Uploading.
MRO is transmitting them now.
Yeah. Or we're receiving them now.
Still in lock with the lander.
Flight, we have seen the transition to surface. EDL is done.
Yes.
Transition,
So transition
to
to
surface.
surface.
All stations
Thank you,
are...
MRO.
I like
What
how
was that last call?
Congratulations, Perseverance team, and the whole team that's not here as well. Excellent job.
That's cool.
Oh, this is great.
Oh my goodness gracious!
Remember,
it's crazy.
these are just the first shots.
Right. Yeah.
Yeah.
These are sort of grainy. The covers over the lenses, they've got dust on them and stuff. So those covers will be removed, and the cameras will.
All stations on
take some
M20
great
EDL
shots.
ops. We have transitioned to surface as reported downstairs. If you're part of that story to the surface team, make sure you're starting to work those inputs, please.
So transition from EDL to surface is EDL is the entry, descent, landing, where they're actually trying to get to the surface safely, and after they're on the surface safely, then they can transmit, or they can transition to surface operations. So surface operations means we're here. What's next? And certainly they have a long list of things that are next.
Yeah. So I wonder, do they just delete all that EDL software now? It's just like, okay, we don't need EDL. We're never going to do EDL again. So. Yeah.
Well, the sky crane deleted itself, and the heat shield deleted itself, and the crew stage deleted itself. So, kind of deleted the software, or deleted the hardware at least.
Yeah.
Again, y'all, we have successfully got confirmation. JPL Mission Control calling in and relaying the information that the latest SUV-sized RC car has been successfully planted on Mars, 35 meters from the closest rocks. They said the closest rocks they could identify from orbit. And it's talking back home. It's sending us pictures. We will certainly have a lot more checkouts to go to make sure everything's good. But we know that we've got some cameras online, and we know that we've got some transmitters online. We've got power, and it is sending us information back live from the surface of Mars. Oh, that's cool.
It's crazy.
My goodness.
Let's see, when it was 2012. So 10 years ago, the sky crane maneuver just seemed like such an insane thing to try. And now they've done it twice.
Yep.
OL1, this is AL2, voice check.
I read you 5 by.
I just want to announce to everybody I've taken a first pass at the surface transition report. I've got some numbers from the script, and I'm awaiting inputs from a couple people still, and confirmation from others. It's ready for review.
Copy.
Sounds
the end
like
of
they
that
were...
was it's ready for review. Are you asking people to take a look at your CASHA report?
That's right. It's ready for review. I'm looking for confirmation from a handful of folks on some of the values before making it final.
Copy. Do you want that confirmation over this net?
The process is to work it over email. I've sent out an email that they can reply to.
Thank you.
They can reply to an email. Sounds like they got some raw data back, and then he said he was running a script, and the script probably processes that raw data and then creates a report, and then he's going to email it around, apparently, is what's happened here. There's an Excel spreadsheet involved, like...
Yeah.
Sorry,
Chris.
I'm updating our landing article from future tense to past tense since it
Nice.
actually landed. Yeah.
Nice.
Oh, yeah.
Chris, did you jump up and run around the room? Is that what I saw?
And did a little dance. Yeah.
I also love the fact that you have shorts on. It's February, sir.
And it's 85 degrees in Florida
geez.
right now. The air conditioner is on in my office. Yes.
Yeah.
Oh, wow.
Some selfies being taken right now.
Oh, my gosh.
Yeah, let me see. Have they tweeted those images or anything like that?
Ooh,
I
good
did.
question. Oh, you
You did? Well, then, all right. Let me go bring up Twitter.
Earlier.
Yeah. Reading? Are you going to edit the article out loud, Chris?
Oh, I'm sorry. I kind of started to there, didn't I? Sorry.
No, it's fine.
TAD
It's
and
absolutely
TAD 1, OL1. Can we go ahead and get handoff ready to go for our final Monte Carlo for today?
This is TAD 1. I'm already working on it.
Copy. Can you tell me what OD that's on?
The latest one I have is 137. I'll go jump into the nav room and confirm that's the last one.
Copy.
Oh, well, this is TAP 1. We're ready to run that Monte Carlo when the handoff is ready.
Copy. Thanks, TAP 1.
What is it? Does anybody know what a
TAD
Monte
1,
Carlo
TAD
is?
2.
It's an
So TAD
analysis.
2?
It's the analysis runs
Sorry.
that they do.
Okay.
TAD 1, this is TAD 2.
Flight Ace. Go Ace.
TAD and TAP.
Just wanted to get permission to release the tracking stations and the NOPEs and everybody.
TAD 2, TAD 1 is currently talking to Nav. Stand by.
Did we see a picture of the clip?
I don't
I
think
they
so.
just meant I think the rocks is what they
Freaking
meant.
Yeah, they were talking about
OL1,
getting a
this is TAD
specific
1.
image.
Go, TAD 1.
I confirmed that OD-137 is the final DoD with all of the two-way data up until 20 gone.
Copy. Thank you.
So again, they're just doing a bunch of reviews of data and stuff like that. Let me see.
I think that is the clip right there. That light part, right?
I don't know.
No,
this is the first one that came back.
Calling TAD 1.
I know that's actually the Martian sky.
I was wondering if you wanted to cancel that last Monte Carlo before we start this one, or if I should get HBC on it so you can focus on the handoff.
Hey, Das, if you go back to the first one.
Go back to where, Chris?
Scroll down. Back to the other one.
5700
The first one?
Yeah. Do you see so the top part of that image, right, where it just turns black, is the underside of the rover.
Gotcha.
In front of it is the sky, and look over to the right-hand side. You see that little area that starts to creep up over the fisheye?
Yeah.
I think that's where the cliffs are.
Okay.
Yeah. So this is actually the body of the rover right here. Right?
That's the body of the rover up above.
You sort of have the wheels. I don't know how much room I have to draw, but there would be wheels over here, and this isn't to scale or anything, and wheels like this, and then the arms that the wheels are on are like this. But this HESCAM is sort of looking out from underneath of the rover forwards, right?
Is there any chance
forwards and backwards? There's a forward.
I don't know if it's forwards
and
backwards.
I don't know which one it is. Yeah.
And so this is the horizon right here. And then, like Chris was saying, right here, I'll delete this so you can see it, but right in that area, you can sort of see a little terrain change right there. See that? Yeah. That's what you were pointing out, right, Chris?
Yeah, that's what I was pointing out.
Yeah.
And Steven, to your point too, it's possible there's other stuff in there, like on the horizon, and it's just the dust on the cover is preventing us from seeing it. But yeah, that looks more like the horizon to me.
Yeah,
right.
You're right. I didn't realize that the black part of the top was actually the bottom of the rover. I wonder if the NASA Eyes app would show the actual orientation.
No, because it wasn't pulling the live data.
Oh, that's right. Yeah, simulated data. Okay.
I should probably retweet that, shouldn't I? Since we're live on the stream. Here, let me click like and retweet. How's that? And then this is another one. This looks like it just barely has the horizon up there. But again, these are all the HESCAMs that sort of look at the ground. You can actually see part of the wheel in this one. Look.
Yeah, you can. Look at that.
Right here, you can see part of the wheel.
Imagine are very wide-angle lenses here.
Yeah.
Imagine those rocks just hanging out for billions and billions of years, and then here it comes,
screaming out of the sky. There's the sky crane of the rover, and the sky crane flies off and crashes somewhere, and the rock's like, "What is happening?" I used to be underwater long ago. And then I've been sitting here in the dusty Martian atmosphere for who knows how many millions of years, and now what is this thing that showed up? Because that is, I mean, Jezero used to be a lake bed, right?
Impact crater.
It's an impact crater.
It's an impact crater, yes.
Okay.
Yeah,
what's with the delta
wide.
though?
Yeah, so it's originally an impact crater. So one of the reasons we're very interested in this area is that there is evidence from orbit that there was water there at one point, but also a lot of what we've.
Everyone.
Okay, we're listening.
Everyone.
Bueller.
Even JPL has trouble talking over each other sometimes.
All right, all stations. Congratulations, but believe it or not, we have a job to do now.
OL1.
End of report. Okay.
Are we ready to look at the handoff?
Surface flight. This is flight.
Yes, please.
Should I go ahead and just share it in the WebEx that we're working now?
Yes, please.
Go ahead, flight.
Top
Just want
one,
to
do we have
confirm
your
that
eyes?
your team is ready to receive Perseverance.
I am paying attention.
Copy.
We are ready to receive Perseverance.
Okay,
are you ready for
the new one is on the left.
Not yet.
The 121 is on the right.
We'll let the team here have... not yet. We'll let the team here have a few minutes with the telemetry, and then we'll do our briefing. Remember to put the details
Sorry,
and capture for your counterpart on the
so
surface
OD
team.
137 spread.
And then we will do an over-VOCA report.
And I don't think anything else actually changes
Flight, this
in
is
this.
Surface FD. Are you staying on Mars 20 ops or
other
switching
than,
to Mars 20 surface
hang on.
ops?
Before I scroll too far down, I want to confirm.
We are going to remain
yes, so
on
we
M20
have
off
the OD112 EPU3.
Copy.
The only other relevant change here is going to be the OD137 spread ESF. And we don't have any other relay orbiter changes, correct?
None that I care for us to incorporate. I don't think so. Tad 1, your screen resolution, I can't actually read stuff very well, but you're saying it out loud, so I'm just trusting that what you're saying is what's there, just so you know.
Copy.
But I think what you described makes sense to me.
And we have no orbiter file deliveries from Monte Carlo this morning.
Thanks for confirming, TAP 1.
Flight activity FNet for 2.
Copy.
And there's no other
Flight
version
nav.
changes.
Go nav.
No other notes. So
nav is going to go off net.
That's it.
Great success
Should
on
we
the
add a note
surface
that just says
mission,
final?
That's great. Thank you.
Final OD from
Nav, you don't want to continue?
Yeah, that's a good
Nothing
idea.
for you to do?
Thank you. TAP,
On
are
to
you
the
good
next
with
mission.
this handoff?
Nav, we want to extend tremendous
Thank you very much.
gratitude for your efforts to you and your team and for giving us a great trajectory here.
You're welcome.
EDL OL 1 or 3, this is EDL phase on EDL ops.
Phase, this is OL1.
Can I get a copy of those pictures sent to me, where the map is, or where we came down, where we targeted, both in hazard map and not hazard map mode?
OL3 gave me a thumbs up. You should have those shortly.
Flight uplink off net for 2.
Copy, uplink.
And again, y'all, we're listening in to JPL Mission Control there. Perseverance has successfully landed on Mars. Not only has it successfully landed, but we've also gotten confirmation back from Mars that it is there. We've got the first images back from the Red Planet. Not the first images from the Red Planet, but these first images from Perseverance, that new rover that has just successfully landed there. And we are listening in, trying to see if we're going to get some additional imagery from JPL here. But Perseverance is safely down on the surface. Of course, a lot of checkouts and stuff like that remain. We're listening to some comms chatter as they hand over to surface operations here and they start running initial reports, but we did get images back from the rover. Means it landed, it had power, it had cameras that were not blown off or anything like that. It was right side up, apparently. The wheels on the ground, and we did... Yeah, it's always good. It's always good. So that is our status now.
Okay, all stations, let's begin our surface handover so we can continue our celebration.
I feel like I needed to have like a... I was about to just chug the entire thing of peanuts, like, while everything was landing, but I don't know. That's just... It's crazy not having any control over anything, just listening in, knowing that it's already happened. Like, whatever has happened has already happened, and we're just waiting for the signal to get here. Remember that 11-minute and 22-second signal it took for the signal to get all the way from Mars back to Earth. And it's crazy just to sit there knowing that that rover is either there taking pictures or it's not there. It's spread all over the surface of Mars or whatever. But all the countdowns, all the telemetry we were getting back, we were hearing the JPL mission controller saying everything was good. The heartbeat coming back, a couple places where the signal dropped, anticipated that it would drop because of the magnetic sheath that the spacecraft basically creates around itself when it enters the atmosphere. But across the board, looking good out there. It's good to have a rover that you can hand over to the surface op team. So somebody came on and said, we've got work to do.
Yes. And don't forget, here in a couple of months, I want to say it's like May or something, they're targeting to do the checkout of Ingenuity and drop it on the surface and fly it around. So we're going to have sort of a similar a similar thing like this. You know, this will be the first time it's ever happened. So there's a lot of really cool stuff coming down the line with Perseverance.
Yep. Oh, jeez.
And of course,
So,
some better photos. There's going to be a lot better photos that come. Don't worry.
And we'll get the exact area that it landed. They probably know where it landed, and they were talking about 35 minutes away, or 35 meters away from the closest rocks that they could identify from orbit. But they're getting all sorts of information, and we may not be live the entire time because remember, these other teams were standing by, ready to go. This isn't like, okay, it landed, everybody go home. It landed. Now it's time to get to work, right? So they are just starting their work now that the rover is down on the surface of Mars. So
the warnings that we do have there for UV are expected.
Talk about some warnings.
AL can confirm, but if you're referring to the ones where the UV trip mask bit on the RPMs changed, those are expected when we unmask under voltage when we transition to surface mode.
Copy.
So basically.
The indication of the tone that we got during descent is likely have cleared, or it's likely on the DPAM.
Correct, Flight. I don't see any indications from the EVRs that indicates that we retripped some RPAM-related monitors. And we'll have to look at the recorded EVRs when we get them down to see what exactly happened. But it looks like, at least what we have so far, that whatever it was has since cleared.
Copy FP.
Yeah. So
Chris.
This is kind of usual. This can sound kind of alarming, especially when you've just landed a multi-billion-dollar spacecraft onto the surface of another planet, and they're talking about an alarm. But this is fairly usual. As the rover is transitioning between everything and its systems are activating, right? You might get spikes here and there that aren't necessarily expected, and the rover just sort of flags them for the team going, hey, that wasn't quite what I expected, but nothing severe, nothing bad. I'm still going on, because a very important part of how we design all of our spacecraft is there's a program that we build into them where basically if they encounter or they think they are encountering a significant issue, they will just put themselves to sleep to stop the issue. And they'll basically just go to sleep and send a signal saying something's gone wrong, tell me when to wake up when it's all fixed. And the fact that didn't happen is an indication that it's not a severe issue, just something they weren't quite expecting, but not a big deal.
They were saying there were warnings that came up and talking about clearing, the warning clearing. Once the warning goes away, they call it clearing, right? Like the alarm is cleared, the warning is cleared. That's the terminology they're using there. So,
and sometimes sometimes too the warnings, not that specific one they were talking about there, but sometimes the warnings are there and they know they're going to happen and they're expecting them to happen. It's just like that extra added confirmation step that yes, it occurred as we expected. That they can use for it.
Right. Yes. So we're not exactly sure if we're going to get any more images. We have those first images from the HazCams that we got back showing the rocks on Mars around the rover. But
okay, so
what happened?
I think Bobak wins. Bobak's tweet was, "Your package has been successfully delivered at 12:55 p.m. Pacific. Package was left in a secure location in Jezero Crater." Yes.
Oh, jeez.
That's great.
The people at JPL have like a notification that pops up on their phone that says. Oh, jeez. Yeah, so it will be a while. It's not like they're going to now launch the helicopter right away. It is weeks or months before they do the helicopter, right?
Yes,
indeed. Yeah, they have a while of just checkouts all together with the whole rover and everything. They have a lot of system checkouts that they've got to do before they really start doing science and even think about deploying Ingenuity.
Right.
And the little robot arm on, if I understand it correctly, the robot has to go get it. And because it's underneath, I believe it's underneath Perseverance is where it rides.
I saw a test of it, and I thought that it came down kind of at an angle, and then, I don't know.
Let me go find it. Let me go find it. That's, yeah.
Yeah, so again, it's not like an assault rover where it comes screaming out of the atmosphere, bounces once on the ground, and then starts driving off towards the cliff to drill some
Slings
holes.
the helicopter out like, yeah.
Throws the helicopter out. The helicopter actually doesn't even land. It just like gets thrown out the side and then spins up while it's in the air and flies off.
Yes, so
it's not an action movie.
Yeah, so what they're saying is that after controllers have determined that the rover, as you were saying, Stephen, is fine, right? Because first and foremost, rover ingenuity, as much as we want it, secondary. After the rover systems are fine and it's functioning, the first thing Perseverance will have to do, although this might be easy given the terrain it landed in, it will have to find a flat area to serve as a helipad for it. And once it finds that, it will then grab the helicopter and put Ingenuity on the pad, and then the helicopters teams will have 30 Martian days from that point to do the flight tests throughout the Martian atmosphere. And what's cool is the minimum safe distance for Perseverance away from Ingenuity is 100 meters.
Really?
Yes, during takeoffs and landings. Yes, so the rover
you don't want to crash
has to back
into
away.
The rover.
That's a good point.
Those blades are going to be spinning like crazy because it's such a thin atmosphere that those blades have to spin so fast. You definitely don't want to risk going anywhere near the rover.
Right. And what's great is we were talking about how the orbiters, right, the spacecraft in orbit, help as communication relays and everything. Well, Ingenuity can't talk to Earth directly. It's too small. So Ingenuity has to talk and send its stuff back to Perseverance, and Perseverance then has to send it up to a rover or to an orbiter, and then the orbiter has to shoot it back.
Right.
At Earth. So even the rovers start serving as communication relays.
Yeah.
Not just for when Matt Damon needs something to talk to, you know.
And they're planning just a handful of flights with Ingenuity. Isn't it like 5 or 6 or something like that? Like first they're just going to go a couple meters off the ground, go back down, and then they're going to progressively get more complex with the flights.
Yeah, I don't know if they have a firm, like, this is exactly how many we're going to do. The limiting factor is really the systems on board and the 30 days that it has to operate in the environment after it disconnects from Perseverance. Yeah. But what's really cool about this, too, because we've spent so much time talking about it, it's worth pointing out, we didn't just send it because it's cool to have a helicopter on Mars.
That's it. We just want to take a picture of it flying and be like, yeah, look, it's a picture of a helicopter on Mars.
Right?
Post it on Instagram. We're done with it, right?
But here's what's cool about it. Perseverance will be able to take pictures of it in flight.
Yeah.
And it will be taking pictures of Perseverance, but its real goal is not just as a technology demonstrator, but to use the cameras and that are on board to help locate scientific areas of interest for Perseverance to then roll up to with its mobile science lab.
Yeah.
It's a
scout.
Yeah. So it's a scout. Yeah. And it's just really cool because one of the things this does kind of directly relate to is the Dragonfly mission, the Curiosity-sized helicopter that we want to send to the surface of Saturn's moon Titan later this decade.
Right.
So this is serving as a technology pathfinder for that as well.
That's just, I mean, that's so cool. We're gonna send the helicopter out there, and the helicopter's gonna take off and then like take pictures so that we can see use that to plan what's going on, almost like I said, like a little scout for the rover. It's solar powered, isn't it? It's solar powered.
Oh yes, Das, I'm gonna put this in. We have to show. I'm gonna put this in our back channel because we have to show this. The crew on board the International Space Station watched the landing live.
That's great.
Nice. And it looks like we may be coming to the end of that camera feed we were getting from JPL there.
Which is kind of what we expected, right? It's a lot of build-up to a very rapid sequence, nerve-wracking event. We get a couple pictures, and then it's usually hours before we know anything else about the state of the vehicle on the surface. So this matches pretty much what we expected. And so many people are breathing easy today with that rover on the surface. And the science that's about to come out of this is incredible.
Yep.
Absolutely incredible.
Yeah. Possible sample returns in a few years.
Yeah.
Oh, that's going to be cool.
Oh, geez. Again, y'all, if you joined us here for the successful landing of Perseverance over on Mars, we did get confirmation that everything is good to go, or everything's good to go. The rover has safely touched down. They're still doing all the system checkouts and stuff like that. It's going to be days of making sure that everything is good to go. But we did go ahead and get that confirmation. Now, let me say, there's been super chats and stuff like that coming in the entire time, memberships, straighten up fly right. I mean, all these people, literally over 100 it looks like in the queue. There's no way that I can possibly read them all. But if you did a super chat, I know a lot of times we try to read out everything, but there were so many things going on, we weren't able to get to everything in this broadcast. We really do appreciate you. Also, if you had a question, we were trying to talk about all sorts of different things, rolling a bunch of questions into one thing. I know there's a ton of questions that came through, and there's no way we can ever get to every single question. We always have to sort of pick and try to use our time wisely. So thank y'all so much for your patience, especially if you did a question that we weren't able to get to. And then also, thanks to everybody who did the super chats. I know we always read those out, and we're not going to be able to for this stream, but just thank you so much. Also, if you popped over to the merch store and you picked up any of the merch that we were doing, thank you for doing that as well. That is another good way to support the stream and make it so we can keep doing this. Apparently, the store guy created
it's real.
It's real in the store. So if you want a way esoteric way to tell people that you were there watching the NASA spaceflight stream when Percy landed on Mars, no one will have any clue what you are talking about if you have this shirt on. It's got my
Unless
drawing
they were there too.
Unless they were there too.
So buying that. Yeah.
That's great.
I'm going to have to get one of these shirts. But
Das
it is
art. Yes.
It's Das art. Apparently that's going to be an entire category of my art on t-shirts or something like that. But I'm going to put a link into chat. I don't think y'all are going to crash the store or anything like that. But here's the deal. The guy that runs the store also said, since it's the new shop, he's going to do a discount code. And so if you use the code WHENSHOP in chat, you get 10% off the shirt there. I'm going to put the discount code into chat. But if you pick up one of those shirts today and you grab one of our commemorative, this is how we commemorate Percy landing on Mars, really? My drawing. If you grab one of those, there is now a Win shop. It's 10% off. It's not free or anything like that, but it's 10% off. I haven't heard anybody screaming in my ear about the store crashing. In fact, if I look at this, I'm going to hit refresh and see if it like crashes out. Hey, look at that. It didn't crash.
It's still there.
Last time we linked the store to 30,000 people, the store completely crashed and we couldn't actually sell anything.
We've sold 1,200 of those shirts already, according to Chris.
No.
Wink. I'm kidding.
He's
Goss.
kidding. Okay.
Like, what?
I know. I'm kidding. I just wanted to see the look
what?
on your face.
Anyways, it is the new store here. We had problems with the store last time. There were so many people watching our live coverage of Starship SN9. The flight, when we mentioned the shop, it literally ground the shop to a halt, which also happened to crash our news article site. So remember, we started off as forums and news articles, and the store was part of the news article site, and we mentioned the store last time, and there were so many people that clicked on the link that it crashed our news site. We've resolved that now, and I haven't seen the store crash yet. So if you did hop over there, remember that Win shop for the new store there. The store hasn't crashed. Okay.
That almost sounded like a challenge.
The boss is telling me the store hasn't crashed yet. So a good thing that the store hasn't crashed. Last time he was screaming over text in the back channel, "Stop mentioning the store, it's crashing the news site." And I think at one point I said, I'm not supposed to mention the store, but that counted as mentioning the store. I got in trouble for that one.
Right.
But anyways, it's sort of a fun thing. There's lots of other things on there, like our Win Hop shirts, but this is my art has been immortalized on a t-shirt,
Yes, I'll take
describing the signal distance, the light, what is it? Light speed minutes, light minute distance between
Light
Mars.
distance.
Yeah, there you go.
Light time.
Or
distance,
light time.
yes.
Light time. Thank you. I can't even remember what to say. So, anyways, folks, just another cool thing. If you pick up that stuff, it's another cool way to support what we do. Hey, also, if you're one of our members, you join the channel as a member and you do that monthly thing. Thank you so much to all our members as well. I know it doesn't always pop up as a super chat or anything like that, but there are hundreds of people now, I think almost over 1,000 people that are doing the monthly memberships, and every single month, whatever tier they're at, just helping us continue this sort of coverage. So it's always a challenge when we do the coverage for live events like this, where we don't have our own cameras and we're listening into NASA mission control. We're trying not to talk over them, but we don't know when they're going to be talking, so we have to sort of listen and be quiet, that sort of stuff. Thank you all so much for understanding. We want to do our own commentary and Q&A and answering questions and stuff like that, but it is difficult for us to, okay, everybody quiet, all of a sudden when we're trying to listen in on those countdown nets.
Well, because we want to hear it too.
I know, it's true.
Yeah.
So that being said, I do believe that this is the end of our live coverage for the successful Mars 2020 Perseverance landing over there on Mars. That new rover, Percy is the friendly name, I guess, is now successfully touched down and has been sending us pictures back from the surface of Mars. But on the NASA spaceflight team here today, over here, we had Steve Marr, one of our photographers and live stream commentators. Steve, thank you so much for joining us.
This has been fun. Yeah.
Absolutely. There's Steve's information up there. He's got that SmugMug link. If one of the mods could put the link to his Photoshop.
I guess I have Photoshop.
Store.
Print store.
Print store. Thank you. It's not a Photoshop. It's a print store, where you can get some of those pictures of Mars launching.
Yeah, and on my main page, I actually have those photos featured on the main page when you go to. And the easiest link is just spacecoaststeve.com. It'll redirect.
I can actually put that in really quick. spacecoaststeve.com.
Yep.
Like that. Oh, and you do. Look at this. You've actually got those images there at the front screen of everything. But you can buy prints and stuff like that if you want some wall artwork or anything like that.
And I have a promo code active. Mars 2020. You'll get 20% off.
Mars 2020 on the Stephen Mars print store. Different than the NASA Spaceflight shop. But another way to support Stephen, what he's doing there, bringing us all those cool photos of what happens at launches and stuff. And then also today, actually, when you got up and did a jig, you took your mic off, so we didn't hear you scream, Chris.
Yes, I didn't take the headset off. The headset came off because it's wired, and I screamed and jumped, and it, stayed tethered and did what gravity does.
Over here, y'all, this is Chris Gebhardt, Assistant Managing Editor for NASA Spaceflight. He's on the live streams all the time, does NASA Spaceflight Live with us, writes articles all the time, Marshall's articles all the time. You can find him on Twitter at @ChrisG_NSF, and you'll see his articles over on the news site, which is just NASASpaceflight.com, right? It's like the place.
In fact, the Perseverance landing article is updated.
See, I feel like I should go and get the Perseverance landing article too. Look, I got this. Here's the article. You can click on that. I can go over here. I can do that. And
which you all saw me edit live on air.
Yeah. It's now past tense. It's not future tense, right?
Yeah.
Nice.
Man, I didn't think about that before writing it, and it was a bear to go through that and change it all from future to past.
It says NASA succeeded. It's not NASA is attempting complex landing. So anyways, folks, John Galloway with NASA Spaceflight, live stream host, commentator, whatever else it is, apparently artist, who's really bad but gets his art put on t-shirts for some reason. Jeez. I do want to say thank you to everybody who makes these streams possible, whether you're a member, whether you're doing super chats that we weren't able to read, whether you picked up merch from the store, whatever it is, even if you just show up and ask us cool questions or retweet things that we tweet or whatever it is, however you're a part of the Spaceflight community, we absolutely appreciate you hanging out with us here today for our live coverage. But that is going to be the end of our broadcast. We'll continue to stand by. We got any launches or anything like that, Chris? I think Starlink isn't.
Well, hang on. Let me.
Yeah.
Boca road closures, but I was going to say, let me pull up this handy little app.
Would that be the next spaceflight?
Saturday is the next launch, although I don't believe we are live streaming it because we won't have anyone there on the ground, but it is the Antares NG-15 mission, which is scheduled to lift off from the Mid-Atlantic Regional Spaceport on Saturday at 12:36 Eastern, 15:36 UTC. And that will take the SS Katherine Johnson Cygnus up to the International Space Station.
I forgot my shirt.
To do that.
You can't buy that one anywhere. That one's mine. I completely forgot about that. But live stream coverage, Antares launching. We're not planning on having a live stream for that because we can't roll anybody out there. Road closures for Boca Chica, I think, are next week. Yeah, Monday. or something like that. So we will also do some live coverage of whatever's happening at Boca Chica, looking for that static fire from SN10. But if you want to make sure you don't miss that, make sure you follow the channel here. You know how that works, whether you're over on YouTube, you're over on the Twitch side, whatever you're doing. Make sure you subscribe to the channel, turn on the notifications, because when we go live, hopefully it's something that you're going to want to see if you're a fan of spaceflight. And if you're new, if the Mars mission has brought you here and you're not normally following these things, you enjoyed the broadcast, maybe come back for a Starship test or a launch or something. This is sort of how we are. We're not official commentary or anything like that. We just have fun and we share excitement with people so that everybody can enjoy what's going on with spaceflight. But for now, John Galloway, Stephen Marr, Chris Gebhardt for NASA Spaceflight signing off, and we will see you nerds next time. Thanks again for everything y'all do, making our coverage possible.
Chamber pressure looks good.
Following up. Roger, roll, Atlantic. Everybody's outside of speed off. Off. Yikes. You bet. Concur. We don't need any more of these.